All right, we are now live, it looks like. Welcome, everybody. This is going to be a fun one. First things first, please support US Art, fighting for your right, my right, everybody's right to own the animals that we love. They help mitigate poor legislation and legislation that's um, made to purposely impose your and my right to own animals. And so US ARC is an important organization for that. It keeps us going to these reptile shows and keeps regulations from becoming overbearing and overwhelming us. And, so we still have our freedoms that we are very entitled to have as, keepers, as responsible keepers. So you can support US Arc by buying merch. You can sign up, go to their website, check out things. Anytime there's some bad legislation that's imposed where they might need help in a particular state, please write a letter to local politicians to oppose these poor laws that are being proposed. And we got the Reptile Super Show coming up. That's in like June. So that's a great show. Just be there. And then also we have Tinley coming up. That's an NARBC show. That's March 14th and 15th. I'll be there. Lots of hognose snakes, some leopard geckos. I think Dave will be there too. I will not be able to make it to Hillsboro, but I'll be in Arizona because same weekend I'll be at the Phoenix show. And that's in April, whatever. I'm going to pour myself a limeade, and we're going to add Nick. Thanks for being here. And then we got Dave with a dunce cap now. What the hell? All right. So the main topic of what we're going to tackle tonight, and this is a fun one. Nick and we were talking about this just briefly before the podcast. Glacial periods and the impact on the locales and the ranges of North American colubrids. And we're going to be primarily focusing on plains hognose and Mexican hognose because this is kind of mine and Dave's channel, and I like talking about hognose snakes. And hognose snakes actually have a very interesting range. And Nick even made a comment about that. Nick, we were talking about like, hey, these things could live all the way down to like parts of northern Mexico, and they go all the way, talk about Mexican hognose, Kennerli, then going into Nassicus, going all the way up to Minnesota and parts of Saskatchewan, Alberta, and Manitoba in Canada, like 50 to 80 miles, north of the United States border.
All right. I think with any really wide-ranging species like that, you're going to see significant. I mean, because it's not like the biome they live in is all the same throughout. From Mexico northern Mexico is a very different place than northern Minnesota or even southern Canada. It's pretty amazing that one snake can live in such massively different climate zones. I mean, you got to feel bad for the ones in Minnesota and Canada compared to the ones further south. Like, got it a lot easier, but that's a pretty durable animal that can handle all that. I'm always a little bit skeptical of the designation of the Mexican hogs as being a separate species, as there's really absolutely nothing that separates them at all. It's just one contiguous range all the way through the continental United States and blowing over into Canada and northern Mexico. So that I'd really like to see a real deep dive in the justification for why is this a separate species. Typically, when things are divided into different species, you have to satisfy a few criteria. You have to show that they're separate. Because if you just have one big continuous range and there's hognose snakes of one variety or other continuously the entire time, and they're clearly going to interbreed where they come into contact, oftentimes what you might have is not really two different species, but a clinal variation of a single species. Yeah, of course, the ones that have the easy life in Mexico are going to look different and be different than the ones that have a very difficult life at the northern extremes of their range. So you would expect there to be phenotypic differences. You would expect there to be differences in habitat. The habitat's totally different. You wouldn't expect them to be exactly the same. You'd be surprised if they did look the same. And, so that always struck me as kind of odd that would be two different species without a clear, coherent sort of explanation as to why are they separate, what caused them to be separate, why are they, things don't happen for no reason. You don't have species won't just bifurcate into two different species, there has to be something that separates them into two separate breeding populations. Something that can be habitat preference. It can even be a dietary preference. It has to be something, though. It's usually geographic. A wide river, an ocean, ice sheet in the case of, you know, some of these things. It's like there's got to be something that causes a population split into two separate breeding populations that continue to breed in isolation and start the process of speciation. In the absence of that, usually you just have a clinal variation of a single species. So.
Yeah, there seems to be like the funny thing is there's not much of a climb through most of plains hognose, like going from, let's say, like their range where they're almost Mexican hognose going all the way up to the north. But there is, and that's one thing I wanted to talk about. There's, you know, you definitely have a bigger difference between, you know, Mexican hognose in, let's say, southern New Mexico and southeast Arizona compared to the plains hognose just like 100 miles north. And also, somebody says they're having trouble hearing you, Nick. So I don't know if you need to move the mic closer. I think you're just a bit quiet.
I don't know if I can move the mic closer.
I'm
having microphone problems here.
It sounds pretty clear, Tyler. What I would suggest is increasing the volume. That might help.
No. His volume is like half or less of your volume. I messaged you.
Oh, you did?
Yeah.
Oh, okay.
My messages. It's okay.
Oh, this might help. How's that? Try talking, Nick.
Sounds fine to me.
Tyler, is that any different? All right, let me see this one. Increase that mic setting all the way up. All right, what about now? Try now.
Any difference at all?
We need to hear from Tyler Mosley. Tyler Mosley, please.
It still might be a little light. It's hard to say. We sound good though, right?
Let me adjust this here. Is that any different?
If you're a little closer, it's a little different.
You're getting louder now. Is that any better?
That might be better.
Whoa, now you're super loud.
Okay.
Let me back that down a little bit. All right.
All right.
Are we good to go?
Yeah.
All right. I think we're good to go. He says he sounded a little lower, but I was like, if you could understand him, that's good.
Roy says I'm too loud anyway.
All right. So the one thing we like, Nick, the funny thing is, like, Mexican hognose. Well, first Western hognose and Mexican hognose were kind of called just Western hognose. That's kind of how that name came about. They were just called all Western hognose, and then they were later like more correctly classified as like, okay, this one is a little different. This is Mexican hognose, and then these are plains hognose. And then they had the dusty hognose, which it would make you real mad because there was really no defining characteristic at all. It's just somebody, I think they just were excited and they wanted to make a subspecies. And the dusty hognose was kind of like defined by as having a lower blotch count and more flecking in their background. But you could find these kind of like what they'd call gloid-eye locale looking ones in like Missouri. There's actually ones in Missouri kind of have that look. Then you can find ones like in Oklahoma or even Texas that had that particular look.
Here's one of those instances, one of the few where I think that breeders of snakes, keepers and breeders of snakes, particularly, it's not often I get to say like the snake morph breeders have a leg up on academics, but in this instance, in this narrow instance, they do, in that academics for the longest time, oh, this population looks physically different than this other population, ergo it must be different, it must be a different species or subspecies or whatever. And there's a million species and subspecies classified on these visual characteristics. And anybody that's a morph breeder who breeds mutations knows that doesn't mean anything at all. Anything at all. Look at the hognose. Look at the plains hognose in your collection that are all pure plains hognose, and look how different they can look with one, not just a gene or two, but a single allele can completely rearrange. Look at an anaconda. Single copy, a single allele. Look at what it does. Now imagine 50 years ago, some academic didn't know anything about that, found a wild anaconda. Well, shit, it must be a different subspecies. Look at this weird pattern. It's not even a rounding error as far as genetic difference. It's one single allele, but it completely changes aspects of color and pattern. So that stuff is really terribly unreliable. It's usually just local adaptation to local conditions, and just a few alleles can change everything. If you look at like a cinnamon ball python, which is a great example, or a zebra jungle carpet for that matter, is the same sort of thing. One allele completely and totally changes the color and pattern of the animal. A second copy of that allele makes a completely patternless snake and literally alters the skull of the
Yeah,
structure
it
of the
does.
skull. It literally, it's now patternless and black, and the snout, it changes, the skull shape is different. One gene does that. That doesn't show up on your DNA test. That doesn't show up in any analysis. It's not enough. But you would, if you found a population where that was common, you'd think there was something special going on.
Yeah,
And it's
true.
not. It's so some of these, like, if you're basing it on just minor aspects of color and pattern, it's probably not valid. You need that's not a convincing argument in most cases. So I would tend to, and I'm a splitter. Like, there are lumpers and splitters in taxonomy, and I'm definitely on the team split for splitting stuff, believe me. But you got to make the case. You have to make a compelling argument, and it can't just be that this population over here looks a little, the color and pattern are a little different. You need more than that.
Sure.
In the absence of those other, and you need morphological differences, genetic differences, and reproductive isolation. It's like a three-legged stool for speciation. If you can't have all three of those things. You have to have some reason you can demonstrate why they are reproductively isolated from their other parent population or related populations. How are they physically different, and how are they genetically different? And if you get all three of those, you've got something different.
Yeah, that's the one thing. So Mexican hognose, like, they were like considered like the same, and then later on they actually did split them. That's like supposed to be in 2003. I think some of those findings may have been off of like Curtis Eckerman studies, but I think that was Smith. And I remember reading about it. I should have read up on that one recently. This was a while ago. I read this like at least like a decade ago. But they found DNA differences between the two, which is like, that's not anything really profound, but it's like they have such a large connecting range. It's like there's no way, and especially just the amount didn't sound right to me, because these aren't like that easy to find species of snake, especially if you need to find them in a specific locale. It's very demanding, but they do integrate in the wild. Like, I never like, it's interesting because like some people are talking about, like, it's not really something that's ever really widely discussed. But anytime anybody asks me, I'm like, I consider them a subspecies. But they were subspecies, then they were reclassified as a separate species. Now, I do think they deserve designation for a subspecies because their morphological structures of their head is different. If you look at the structures between a Plains and a Mexican, the big one, here, I'll pull out the puppet. I'll show you. Now, this is a copy of a Plains hognose, but it's not great because it's mostly smooth. So you can't, but the Plains hognose, the scales behind the rostral scale here, the main, you know what the rostral scale is, but between these prefrontal scales here and here, these cluster of scales, these are the azygous scales. And Plains hognose generally have like 6 or more. Usually it's more like actually 8 or more. They can have like a dozen. It really varies. But Mexican hognose always have less azygous scales, and their structure of their head, the anatomical structure of their head is definitely different. So I definitely see some minor morphological differences.
The stuff like heads, structural differences to heads is almost certainly just a local adaptation to diet. I don't know what
their diet is different.
I don't know what a Mexican hognose is eating versus what a Minnesota hognose is eating, but I can tell you they're eating different things because they're such very different biomes. And so skull structural differences are almost always adaptations to what you're eating.
Sure.
So
I wonder.
that could be as you get further and further south, you eat more of this other thing, and so you tend to see these tendencies. To really prove a case that these are different species or subspecies or what have you, you would need to have like really robust sampling throughout the entire range, particularly in the intergrade zone or hybrid zone between there. Because if you just take if you have a handful of specimens from the northern end of the range and a handful from the southern end of the range, it's not really telling you much. It's telling you would expect those things to be different.
Sure.
At that point of contact, do you gradually just become more northern or southern as you go throughout? And what does that look like? The nature of that overlap zone, that's what really will tell the tale.
If you go to like places like where is it? Fuck, I know it's like Midland, Texas. If you go to Midland, Texas, and a little south of there, like Midland, those are Plains hognose, but they do look a little different. And if you keep going a little further south, some locales it kind of looks almost like a Mexican hognose. I've seen some people catch ones like that looks like a Mexican hognose, but they're in the same range. And so there is this kind of like cline, and it's interesting that because what you say that, hey, this little bit of a head structure difference could be dietary, because the ones in like southeast Arizona, like I was actually herping in one area where they do find a lot of them. Unfortunately, you didn't find a Mexican hognose that day, but it's, you know, it is kind of similar to where I'd find them, let's say in like Minnesota or Nebraska. There is some similarities. I'd say it's definitely a little more, you know, dry there. They don't get as much rain, but it's very loose, sandy soil with a lot of abandoned rodent burrows. And it's near adjacent to like pools of water, have the higher populations because that provides, you know, more prey and just a more sustainable, you know, habitat.
Yeah, I would be. I'd be really interested to see. The problem with these things is there's a certain amount of vagary that goes with any sort of taxonomic designations, and I think a lot of people don't really understand that taxonomy isn't a real science and it's all just made up. It's all made up, and the rules are almost non-existent. It's just like it's the most nonsensical thing, and we think like every time a paper comes out and somebody like, oh, it's like there was a crappy paper on Antaresia that came out a few years ago, and like the authors just came to some really bizarre conclusions that I don't buy. I don't believe their conclusions. I don't like their methodology. I don't like the paper. So I don't accept it. And you know what? I don't have to. And neither does anybody else. That's the thing. But at the time, this paper said that, you know, Stimson's pythons and children's pythons were the same species, even though their own genetic data clearly showed that wasn't the case. But whatever. But there are a lot of people that chiming in on the internet, oh, well, it's official now. They're all just children's pythons. Like, no, it's not official. It's never official. There is no such thing as official taxonomy. They were all Western hognose. And then there was a subspecies. And now they're a full species. You know what? It could be nothing. Or you as every individual can read that paper and make up their own mind whether to accept this at the level of species, subspecies, or say it's all a bunch of nonsense. I don't accept it at all in any form. And that is all perfectly valid. Taxonomy is never official. All paper that designates a new species and gives it a name, all they're saying is that in the opinions of these authors, based on their evidence, this is what they believe is going on. And anybody, whether they're an academic or a layman or anybody else or somebody in the hobby, it doesn't matter, can read that and just do with it whatever they want. Ignore it, endorse it, believe it, not believe it. It's never official. It's never official. So this idea that things are official is problematic in the hobby. People think, oh, well, somebody published a paper, so that must be what's going on. It's like, yeah, there's a lot of papers that are absolute garbage. Garbage.
Sure, yeah. I think it's like people, of course, people want to have like black and white answers, but like you're saying,
never that. It's
what taxonomy is very subjective, and the DNA, and then what you're considering, what's, you know.
Yeah, and that fun fact, there's no rules at all. The rules for naming a species were set down over 200 years ago by Linnaeus. It's basically just write up a description of your species and tell us how we can identify it from related species. Print up like 100 copies of it on paper and distribute it within 100 miles of your house. That's basically the whole rules. Because in the 1790s, that seemed like a reasonable thing. There's no provision in the ICZN code, which is the International Code for Zoological Nomenclature, the sort of governing body that does very little in the way of governing taxonomical nomenclature. There's nothing about DNA because the rules were written down before we knew what DNA was. So
sure, that makes yeah.
How much genetic difference is required to be a species or subspecies? Fuck knows. Whatever you feel like, whatever the person who writes a paper feels like, or not even do any DNA, doesn't even fucking matter. The vast majority of species on Earth were classified with before we knew what DNA even was. Like, it doesn't matter. Like, how much is different? It's like, so you see different people in different groups classifying things with wildly different methodologies, and there's no rhyme or reason at all to any of it. It's like, and in every area of taxonomy, there seems to be a little sort of cabal of academics who are the guys who write all the papers on that little thing, and their opinion seems to hold sway. Not because it's right, but because they're the guys who write the papers on monitor lizards, which is it's the same guys.
The monitor lizards. Yeah, don't get Nick started on the monitor guys and the classifications.
So fucking ridiculous. It insults my intelligence, and it should insult yours too. It is absolutely absurd. It's fucking absurd.
I never really thought about it with the
Absolutely
monitors. Yeah,
you have probably a dozen genera of monitors at least. Yet they're all in Varanus. Yep. So you have a giant monitor clade that's venomous. I mean, that's your Megalania, which is now extinct, unfortunately. Your croc monitors and your Komodos. Yet that's the same genus as the tree monitors, of which there's like 7 or 8 species. This is some undescribed ones. Like these tiny arboreal. Obviously, all these tree monitors belong together in their own group. What do you call a group of species that are more closely related to each other than they are to anything else? A fucking genus. That's the definition of a genus. They are obviously a genus. There's a mangrove monitor genus. There's a water monitor genus. There's a bunch of different genera of all these, that you know when you see them. It's like, this is obvious. Like, what are we doing here? Why are we pretending these are all in the same genus? It's absolutely freaking absurd.
Yeah, that's one of those ones where it's kind of like visual. They look the same, so they say it's the same genus.
Run the DNA, and there's only the one genus. Because why there's only one genus of Varanus? Because the guys who write the papers believe that's their position, that all of them are in the same genus. Doesn't matter if that would never fly in literally any other area of biology. Nobody else would ever do it, but those guys do it, and that's what people don't question it. It's insane. It's absolutely insane.
All right, Nick.
And you see this over and over and over and over again with other things. It's like where there's just these sort of absurd. That's just an obvious example of the absurdities. The absurd. Why are the short-tailed pythons in the world of pythons, which is closer to my wheelhouse, are clearly their own genus? There's 3 species. They are anatomically and biologically very, very similar to each other and worlds apart from anything else. Why are they in python? They should have their own genus. It's stupid. It doesn't.
No, I see what you're saying. I mean, because blood's like the short tails. Sorry, there's one guy because I said Borneo blood python once, and this guy in the comments goes, "What's a Borneo blood python?" He goes, "I've never heard of that." Because what are you talking about? It's like, oh, sorry, it's short tail python. Sorry.
As a fellow old timer and everything, I sometimes still, because we used to call them all blood pythons.
Yeah, you used to call them all blood pythons.
Oh yeah, but it's the same. It's the same. It's ridiculous. It's ridiculous. By the same token, also in pythons, why does the genus Leopython even exist? It shouldn't even exist. There's no justification for having that genus exist, because they should all be in Bothrochilus with ring pythons, which morphologically, genetically, they are all in that same group. So that's the older genus. So there should be no Leopython at all.
All right, Nick.
I'm not gonna use that name. I was like, because I don't have to. Because it's the beauty of it. It's all just made up, and you can go with whatever you want. You don't have to follow with this insanity.
So Jeff, I don't think it's time to change gears yet. I think we should leave more a little bit.
Well, I was gonna ask Nick. I wanted to ask her, like, all right, based off of the brief information I gave you, is Mexican hognose a subspecies or is it the same species? Nail it right now.
If I have to choose one or the other, I have a really hard time figuring out how it could possibly be a full species.
Well, no, I mean subspecies or same species. You think that it even deserves subspecies designation? I mean, they do have some anatomical characteristics are different. Morphologically, they are slightly different. The azygous scale count behind a rostral scale, a little different head structure.
There's a hypothetical scenario that may well have played out with this that probably bears mentioning that would have bearing on that answer, and that is sometimes you can have things. There may have well been at one point, and likely was, some sort of biogeographic barrier that kept the southernmost population of hognose separated from the rest of the plains hognose. During that time when this barrier existed, they began speciating. Scale counts changed. Everything, they started to change and partially diverge into separate species. And then whatever the barrier was is not there anymore. There is no barrier now. So if they're different, once things separate, they don't necessarily always stay separate. They can separate, and then whatever is keeping them apart can go away in some cases, and they can come back together. So you might have had a partial speciation event where they started to separate into separate species, and then whatever was in the middle that was keeping them from interbreeding is no longer applicable, and those populations come back together. And this has happened over and over and over and over and over again in a ton of species, in humans, in bears, in anywhere you look, you'll see these in our own. We know that our ancestors and the ancestors of contemporary chimpanzees split 7-8 million years ago, and then about 1.5 million years after we split from them, we got back together and interbred with them again, and then we split a second time. And after the second time we split, it took, because we had a chromosome fuse situation where 2 of our chromosomes fused into one super giant chromosome, and that prevented further integration and hybridization. But we split, went our separate ways, came back together a considerable amount of time later, interbred, then split a second time. That kind of stuff happens in animals and things all the time as well. So you might have had a speciation event, and then the reason why they're different at the bottom is that whatever that barrier was is no longer at play. So now there is continuous gene flow, but you still have pronounced phenotypic differences and even some genetic differences at the opposite end of the range, at ends of the range, but no barrier in the middle now, because the barrier, whatever it was, is gone. There's that occurs in Australia. In Australia, there's a, most people are into pythons, so the diamond pythons and southern coastal carpets interbreed, and there's a well-defined sort of intergrade zone, hybrid zone. Intergrade is the wrong word because they're so different genetically on either side that there should easily be full species, but they hybridize. There's a stable population of intergrade animals in the middle, and it's not just them. You see that same pattern in some birds, some skinks, in a lot of the animals that have that same distribution. There's also this hybrid zone, and it has the signature of there used to be something keeping these things apart, and whatever it was, we don't know what it was, is not there anymore. And now they can come back together, and you have this sort of like blending where the southernmost and northernmost are different, and that there's this band in the middle where they've hybridized because the barrier is no longer there. And that may well be at play with the hognose. There may have been something that is just not there now.
Okay, that's what we talked. I told you I talked to that Corey Rolk, and he did this webinar. I told you about it. He had a summary. I cannot find it. Luckily, sometimes they retain certain information, so I read it a year ago. I reached out to him, and he does say, and he said they are going to be working on a paper. But there is the theory that there was a glacier or something that divided them for a number of years, tens of thousands of years, and it slowly went away. I mean, here's the thing: even if it wasn't something like a glacier, it could have been something like you said. It could have became like more like desert or too harsh for a lot of species to live there at that time. And
that is probably more likely than a glacier, because that
because it's far south. It's like, what the fuck's this glacier doing out of place? This glacier's out of control.
One thing people don't realize is that when you lock up a huge portion of the Earth's fresh water into glaciers in the northern hemisphere, in Europe, in Eurasia, and in North America, so much fresh water is tied up that the overall climate is colder but noticeably drier. So it's actually more arid. So the deserts tend to expand, and you get so the drier areas get actually drier during a glacier because there's not as much water to be for precipitation when it's all locked up in these ice sheets. So you might have had a band of, you could easily have had a band
desert,
of just,
like that
desert that's just too damn dry, and it kept them further south. I kept these things south, and then but if that's the case, you would have had, this would have been a situation that wouldn't have happened one time. This would have happened over and over and over and over again, between 10 and 20 times in the last 2.5 million years. Because the advance of ice sheets in the northern hemisphere and this glacial interglacial cycle has happened. It's a little hard to pin down exactly, but at least 10 times, possibly as many as 20 times, depending on what you consider a proper ice age, because some of these events are not as extreme as other events, but at least 10 good whopping ones. So this process of ice advances, pushes all the hognose that are in the northern portion of the range, because it's not like a hognose snake's going to be living at the foot of a 2-mile thick sheet of ice. There's going to be a band along the edge of that where it's just too cold. It's going to push the range further south, and then it's going to move back north as that ice retreats. And that's going to happen over and over and over and over again. And every time you have the glaciers advance, it's going to get drier. So you might have a desert that's kind of comes into existence and then dies back, and it's doing this too with the advancing ice. And so you might have a situation where the reason why the West Mexican hogs and the Plains hogs are different, but not totally different, is that, okay, for the Pleistocene period, the last 2.5 million is the last 2.5 million years. It's also referred to as the Quaternary Ice Ages. That last 2.5 million years, most of the time, it's been ice. 2/3 of the time, it's ice. Maybe 1/3 of the time, it's an interglacial like now. Most of the time, it's icy conditions. The interglacials are smaller periods of time in between the icy periods. So these icy conditions with this arid band, if there was one that they're hypothesizing, would have been the dominant feature of the North American biome, if you will, for most of that 2.5 million years. And there's just like brief periods of time that we happen to live in one now where the ice is retreated and these things come together. So over time, if you have like a population that splits into two, comes back into one, splits into two, comes back into one, it does this, they will maintain somewhat separate identities. And the fact that the majority of that time they would be separated and a minority of the time they would be together, you would expect there to be phenotypic differences and you would expect there to be genetic differences. But these periodic interglacial periods would mitigate the genetic differences to a fair degree. So you wouldn't expect massive genetic differences, but you'd expect some. And that's kind of what you're seeing. That's consistent with what you're seeing with them.
So it's consistent with what you're seeing. So that's just pretty cool information. And so, yeah, so this is going into the glacial periods affecting livable areas, the climate, locales. Now, Nick, about I think they are around 10 to 13 million years. In southern Nebraska, they have fossils where they call it Paleoheterodon titheni. So they discovered essentially, an old ancestor of plains hognose in southern Nebraska. And they said the main difference was a structural difference in the head and the teeth, but it wasn't like that major. So they say like Heterodon's been a prairie survivor for like 10, 13 million years. Now, do you think that species could have completely died out, or do you think these are could possibly be, ancestors from 10 million years ago, since they did find fossils in southern Nebraska in an area where, you can find a lot of plains hognose now today?
To me, it seems more likely that what you have now, and these are kind of like, again, where taxonomy is kind of made up. If you look at a fossil of a hognose snake that's 13 million years old, and you look at its direct linear descendant 13 million years later, and it's a little bit different, you say, well, this is a different species. Is it one species, or is it two? When did it become two species? When did it turn into a different species?
Well, I think it's like
slow. Every single offspring that's ever existed was the same species as its parents. There has never been a time where two animals mated from one species and produced a new species. Every offspring for everything is the same species as parents. But over time, eventually, we start calling it something different, which is a bit nonsensical.
Okay.
But it is kind of but there's never a moment where they're like, the light bulb goes off, oh, now it's a new species because of this. It's never that. Slowly things can, and you see this all the time, particularly with recently extinct species. If you look at, like, we classify bison in North America as a different species than the bison that are living today, even though the ones that are alive today are those same bison. They just got smaller. Well, during Ice Age, they were bigger. So that's a different species. That's a steppe bison. It's like, really? These are the direct these are, it is 20,000 years isn't even that long. Why are they different species now? It's like, because they're a little smaller. It's like, these are the kind of things we're talking about. It's, I sometimes think that taxonomists get in our way of our understanding of things, because people who don't know how to interpret that sort of data, they tend to think of this as like a very cut and dry sort of thing, and it's not. I mean, some of these things are a continuum. If you look at human evolution, it's like there's no point where we just magically became, we're Homo sapiens now. It's like, nah, it just keeps going back.
Yeah, evolving. Yeah.
Look at the oldest Homo sapiens fossils ever found that they attribute to Homo sapiens, which I think is a bit sketchy, but they're from Jebel Arhoud in Morocco.
And they're not attractive looking. They don't look good.
Yeah, you put a ball cap on them and then you see them at Walmart, you wouldn't have thought nothing. But what do you see? A less prominent chin, a more prominent occipital torus above your eyes, and a lower brain case that's a little pointy in the back with not occipital torus, but a ridge at the back for muscle attachments for a stronger neck. It's like primitive, archaic features, but this is us. But it's like, you can see it's really is a continuum in a lot of cases. There are cases where things go off quickly, but a lot of times it's a slow buildup of traits that are beneficial over such a long period of time, but there's never an aha moment where one thing becomes another thing.
You're talking about looks maxing. You're talking about looks maxing right now.
I'm just saying, I think it's...
Do you know what that is? It's a meme.
I'm too old for this for media discussions. Like I'm so crusty and old. Like I'm.
Well, you're talking about the orbital differences and stuff, and it reminds me of these memes where these guys like they basically talk about like good facial structure and stuff like that.
Yeah, I'm just saying like these sort of features we associate with being archaic and older. They show up. It's like there was never a point where. It's like where this just on this day in this generation it became a new thing. It's not really like that, really. It's so much more gradual. You'd never notice it. Snakes also sort of found the ideal body plan pretty quickly and don't really evolve very quickly. So a hognose snake from 13 million years ago weirdly looks just like a hognose snake. You know what else I bet?
Because it works. Yeah.
I'll bet you can't see its color and pattern because it's just some bones. And I bet you the bones are shit too. Snakes, small ones especially, don't fossilize for crap. Usually when you find some fossils, it's like, oh, it's a half of a lower mandible and 2 vertebrae and 1 rib. And that's the total thing. Like all the bones you found from that snake could probably fit in a thimble. And that's all you ever get because they fall apart. And the bones get smashed and scattered. And you don't really ever find, it's super, super, super rare to find like an articulated snake skeleton. It has to be incredibly rare to find those conditions.
They talked about that in the short article about the hognose, remnants they found. They found one pretty good fossil, but they said all the other fossils they found in like North Nebraska, they said they were just vertebrae, but they could match them and they could tell it's the same. But they didn't know anything until they found one pretty good fossil of its head, which they basically stated what you did, what you just said, that it's pretty hard, especially for these small species, to find them intact. That one, I guess, was pretty intact.
It happens, but it's so unbelievably rare. So what you find is they're extrapolating out from like incredibly small fragments of something, and then extrapolating out, making grand proclamations based on really, 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 really tiny bits of evidence. And there's also interspecific variation between individuals. If you were to take my skull and your skull, and you were to, strip it down to nothing but bone, and you took a bunch of measurements, you would find that my skull is shaped differently than yours. The width of my jaw, the length of the angle of my chin, the slope of my forehead, how much of an occipital torus, i.e. a brow ridge, do I have? How wide is my nasal opening? You will find that your skull and my skull are different, yet we're clearly the same species.
Yeah.
So it's like you would find those slight differences, wouldn't you? It's like
Nick's trying to mog me right now.
What I'm saying is like you can't, if you only have one halfway decent skull, it's like you can't really draw too much inference from that. It's like, it's similar, but you need a lot of that stuff to see are there consistent differences with contemporary populations to really say a lot. But I would go so far as to bet you that the color and pattern of that 13 million year old hognose snake was probably really similar to a living hognose snake, because that stuff almost never changes. If you look at
it, makes sense. Yeah.
Look at a Dumerel's boa, okay, and a Madagascar ground boa. On frickin' Madagascar, their last common ancestor, boas are a super old lineage, over about 100 million years old. They diverged from other snakes in the Cretaceous. They're that old, way older than more than twice the age of pythons, which are only about 50 million years old. But boas. To be a boa in Madagascar, they would have last had a common ancestor with a South American boa constrictor. Their last common ancestor would have been probably 50 to 60 million years. That's unbelievable amount of time has passed. And when you look at a Madagascar ground boa, or you look at a Dumerel's boa, it kind of looks like a boa constrictor still, doesn't it? A little bit, right?
Yeah, a little bit. They kind of
Isn't that funny? Yeah. Still kind of looks like a boa. Not exactly, but it still kind of looks like a boa. If you look at all the Australian pythons, you'll find commonalities of pattern. They last shared a common ancestor about 25 million years ago, yet they almost all still have a double neck stripe, a skull and crossbones of the head, that double neck stripe and everything, and a lot of them have red babies still. So yeah, because that's still the ancestral state from all of them. So it's like, I'll bet you your ancestral hognose at 13 million years ago probably looked a lot like it's pretty recognizably a hognose snake.
Yeah.
It probably was doing hognose stuff, living like a hognose, looking like a hognose, just in an earlier period.
Right.
During the Miocene.
It's cool though, because it just shows how resilient they are, and how adaptive and how they've been able to evolve over the years. So And then we're going to talk about this one now. I know, Nick, I talked to you a while ago about this one, and you said you were slightly skeptical of it. There's that one article. I'm sure. Did you read that one too? They showed that the plains hognose snakes have some like ancestral DNA from Asian origins, like snakes. I don't know what they're comparing it to. They think they crossed the Bering Land Bridge about, was it, I don't know, would have been 30, 50,000, or how long ago? How many, or would that have been millions of years? That would have been millions. Sorry, it would have been millions of years.
There have been, the land connection with Asia via Alaska has existed multiple times for long periods of time, not just in the Pleistocene. There's been, well, okay. We had elephants. We had 5 species of North American elephant that walked over here from Asia. We had camels evolved in North America, as did horses, and they walked the other direction into Asia and ultimately to Africa and Arabia. So, like, this has happened. This connection has been there intermittently for a long period of time. Not just the very recent past, which it was then too, but multiple periods of time.
So 30 million years ago, some snakes that could have been looking somewhat like a hognose snake could have been in that range, and slowly, the range could have slowly inched east into the central plains, and they slowly evolved into what Heterodonascus is today. You think that's plausible?
You would have to find a period of time where temperatures would allow for that. You need to have a land connection with, which is hard because as global temperatures are higher, and the habitat would be more amenable to making that crossing for something like a reptile, you tend to get high sea levels. Warm temperatures equates to high sea levels, and cold temperatures is low sea levels.
Sure.
So you'd have to find a period of time where, and these periods of time have existed. So, yes, but that might have been a very long time ago.
Like, what do you think, 30, 40 million years?
Hard to say. I would have to look up that. I would have to research that specifically.
Okay.
What you'd be looking for was, when was the last time you had a warm weather connection, where global temperatures were high enough, but you still had connectivity. That area that's submerged is called Beringia.
Okay.
When was the last time Beringia existed in a warm period of time? And
I think it's like
recently,
30 million years ago, because I looked it up. That's why I keep saying 30 million years. But that was good. I think that's what it was. I think it was 30 million years ago. I'm not positive, though. I didn't read it too recently.
Yeah, that's when you're. Although usually, when you start going down the rabbit hole and researching these sorts of things, you'll find the smoking gun. It's like, when was the time where these things aligned, where there was a land connection that allowed for migration of more warm weather dependent species, and you'll find it. Usually the problem with researching that sort of stuff is that the climate records and the climate papers don't care about animals. And the animal papers don't usually research the climate. These are totally.
Well, what the fuck do they care about then?
They're totally different scientific disciplines. So, like, the geologists that want to study freaking Beringia and everything, and the climatologists who study this sort of stuff, the geologists are studying it for their reasons. Climatologists are studying it. Botanists are studying it, but they're not. No one person is studying it for all these reasons. So you have to, like, get into other scientific disciplines and kind of overlay all these lines of evidence, and then you'll figure it out. But it sometimes
gotcha.
laborious.
Well, a climatologist would probably be the best one, because he's going to be telling you, he's going to find out the temperatures, and you can just see, and like, does this look good or not for survivability for a species.
Yeah. Well, if it doesn't need to be super warm, look at but also animals that migrate, the people that migrated across Beringia, all that stuff, nobody ever consciously did anything. No animals, no mammoths migrated to the New World. They just were hanging out where they were, and they might have wandered a few miles further every generation, and over a few thousand years, you just kind of gradually your descendants end up in a place that you weren't originally from, and nobody ever knew they went anywhere. It's like the first humans to make it to the New World were like, oh, let's go migrate to the New World. It's like they had no idea. They're just following seals and shit and kayaks along the coast. And eventually, it's like if you set up your base camp on the coast and you moved 2 miles down the beach every year, within a couple thousand years, you'd be all the way to Argentina. You just, without ever really no one individual person ever moved more than like 8 or 10 miles in their entire lifetime, but gradually, generationally, over a relatively short period of time and generations, you move a tremendous distance. And the same with animals, be they snakes or elephants or horses or camels or any of this stuff. But yeah, there's a reason why when you talk about Beringia, if you look at the wildlife sort of composition of Siberia and of Canada, it's the same. It's like the same bears, the same everything. That's why there's Eurasian bison, and there's also bison in North America, because they just walked there. The elephants on both sides are the same. The bison were the same. There's all this stuff that's the same. The moose, they've got moose. It's the same moose that you find in Canada, you find in Siberia. It's the same moose. It's not a different species of moose, because all that area that is now submerged was that same biome. It's called the taiga forest, and it goes from Siberia all the way to Canada, all the way through Canada, in this huge belt of contiguous forest. And the submerged link in Beringia was that same forest. It's just now that it's broken because that part is now underwater. But that's why you have such strong similarities in those biomes and in those species in east and west of that. Even the people, this is how recently this has happened over the last time. You have native Siberians on one side of Beringia, and you have natives in Canadian Alaska natives on the other side. And they don't speak exactly the same language, but they sort of speak the same language still. It's been so recent. Like, if you put them together in a room, they could understand each other. They're not speaking the same. They're speaking like very different dialects of the same thing. They can still get each other's meanings because the root words are still the same. Because they're the same freaking people. Like, that were like, you know, on either side of this. Because it's not, like I said, and most of the last 2.5 million years, it was dry land.
Yeah.
And weirdly, mostly free of ice. So you had like the Laurentide ice sheet, which is the entirety of Canada under 2 miles of ice on the east side of the Rockies, and it went all the way down to the Great Lakes into like Ohio and Iowa, where parts of Iowa were covered in ice. It went that far down. And then on the west side of the Rockies, you had the Cordilleran ice sheet. So the dividing line is the Rocky Mountains and everything, and that didn't go quite as far south. It went right basically the edge of the Canadian border, right where I live in eastern Washington State. I would have been an hour drive from the edge of the ice sheet if I drove it north for an hour. And the geology of Washington State is entirely dictated by the retreat of that ice sheet. There's massive areas like dry falls, the channeled scablands, all this stuff there's all these dramatic geological features in Washington State that are the result of that melting ice. The Willamette Valley in all of Oregon that Portland is in, some of the most fertile farmland in the United States is the Willamette Valley. And all of that was carved out by the Lake Missoula floods, because as the Cordilleran ice sheet melted, you had glacial Lake Missoula. You basically had a lake the size of Lake Superior west of the Rockies called Glacial Lake Missoula. And eventually it got so much pressure built up that it lifted the glacier up that was blocking it, and it flooded all the way to the coast in a catastrophic flood, the biggest flood ever in the geologic record that we know of, all the way 350 miles to the Pacific Ocean. It carved out the Willamette Valley in Portland. It carved out Dry Falls, which kind of looks like the Grand Canyon, except for it was carved out instantly by that much water moving. And this happened a few different times. So, yeah, that's why Coincidence Rockies are also the boundary that keeps hognose snakes, the plains hognose, from the reason I can't catch a hognose snake where I'm at is like I'm real close to the Rockies, but I'm on the wrong side of it.
You are.
So it keeps these ice sheets separate. That's the boundary that keeps the hognose snakes only on the one side of it.
Now, Nick, this is going to be interesting to you probably. I mentioned this to you months ago, I think. But if you have like plains hognose, like mixed locales, let's say Texas, Colorado, and you incubate their eggs, and you incubate their eggs at the same temperature as eggs from a hognose that's like pure Minnesota or pure Montana, those locales from the northern areas of Minnesota, Montana hatch faster than your more southern and central locale hognose. You'll actually see them hatch out like 5-6 days sooner at the same exact temperatures. And even if you mix the locales, you'll still see a little bit of disparity between, like, if you breed your Montana hognose to your mixed locale hognose, you'll see those eggs hatch out like a few days sooner. So these northern species definitely have, adaptive, DNA to these colder climates, so they can metabolize at lower temps. They have shorter, periods to eat, and to, just be active. They have longer brumation periods. And so they're more opportunistic feeders. That's why some of these northern locales actually make better feeders in captivity. They tend to be a little darker. Like if you go to central U.S., they can be lighter, sandier. You can get greenish gray ones. You can get, brown. You get like a lot of different phases. But if you go to the far northern locales, they're pretty much just dark. They can be gray. They can be really dark brown. Some are really deep colored. You can get green phase, but you don't really ever get the red phase or the really sandy colored ones. And this might be interesting also, Nick. There is one locale, or actually a few locales, that are east of the Mississippi River in Illinois. So the plains hognose are in this big channel between the Mississippi and the Rockies, but there's actually a decent population in Illinois. And at one time, I think they were very dominant. But most of their habitat, of course, unfortunately got destroyed through development and, agriculture.
Also, something else to think about, if rivers are often by big rivers like the Mississippi can be pretty effective barriers to animal movements. And that's well known. But rivers move, rivers change, river courses change a lot over time. And in the 13 million years that hognose have, at least, that they've been around, that river has moved a great deal. It has not just been going the same. It's like
right, yeah.
Rivers change course all the time over large period time scales and everything. It's like if you go to Cairo, Egypt, which I've been fortunate enough to go to and been inside the pyramids and stuff in Cairo.
Ooh.
One thing you'll notice is that like the pyramids are nowhere near the Nile River at all. Yet they all have what's called a valley temple, which is a long causeway with a temple where they attach a dock at the river, but the river is nowhere near that now because there is, and you can see from satellite image, you can see there is an entire branch of the Nile River that dipped right up to the base of those pyramids that aided in the construction and everything that has just dried up over the last 5,000 years. It's not there at all. So now they're just kind of left high and dry as the river has meandered off course or on due course. Water just flows through the path of least resistance, and if enough things change over a long period of time, it'll move. Even where I'm at, there's a river that's totally changed course because of Mount St. Helens in river changed course in one day because Mount St. Helens blew up on May 18th of 1980, and there's a river. There was a lake called Spirit Lake, and I think it was the Tuttle River that fed into that lake. And the lake no longer exists. It went away in one day. The lake was completely gone, and the river, the river changed course and now wraps around because it's just flowing to the path of least resistance. So in a single day, in an afternoon, a lake disappeared and a river changed its course because of one event. So that sort of stuff happens. So you can see we're a situation where the Mississippi might have kept the hognose here, but then the Mississippi might have just moved over here and left a population of hognose that was doing fine in this habitat over here. And you might have that, what do you call an extra liminal population on the wrong side of the river.
Interesting. Okay. And Dave, were you about to say something?
So your comment about the Nile River, I take it you don't think giants or aliens made the pyramids?
No, we live in an age of just rank stupidity in this. It's just absolutely ridiculous. Like this, we know exactly how they built the pyramids. You know why we know? Because they fucking drew a picture of it. Like we have tons of data on this. This is not like there's all these like weird conspiracy theories on the internet of people. Well, we don't know. It's like, yeah, we totally do. Like, you know how they did it? Wooden sledges and a bunch of people pulling across the sand. And like, well, that's really labor intensive. You know what the trick was? Pour water on the frickin' sand in front of the wedges, and it cuts the friction by 50%. So you can do it with half as many people. There's a well-known inscription, like a relief carving, that shows this, and they always interpret it like there was some ceremony. There's like a couple these must be priestesses pouring some sacred libation on the ground in front of this block they're dragging and everything. It's like, nope, just water. Just you pour water on the sand, it cuts the friction in half, it moves that much. It's twice as easy to move that block. It's just that easy. We have remnants of the ramps. Some of the other minor pyramids they built through construction, they made them out of mud brick. Some of the ramps are still there. Some of the mud brick is still there. It's not a mystery at all. It's like, but the internet loves a mystery.
They do. Yeah, they don't like the simple answers aren't really fulfilling.
No.
Now, what
like,
about this one, Nick?
It's actually,
we have some evidence that this may have been a UFO that they were worshiping. What do you think about that?
that's absolute fucking nonsense. You want to know what that is?
It looks
That
like the sun.
That is I'll tell you who that is.
Who is that?
That is the pharaoh named Akhenaten who invented monotheistic religion before the first person on the earth to declare the existence of a single deity, a single god, was that individual, Akhenaten, the father of Tutankhamun. Said all the old gods are nonsense. None of that's true. There's only one god, represented by the sun disk, which we will henceforth call the Aten. Thus, he changed his name from Amenhotep III to Akhenaten. That is his royal name, and that's what that is. And he built a new capital city, a place called Amarna, which is south of Cairo. And when you do that, it was a pretty good business to be in, being a priest in ancient Egypt, and so he got a lot of pushback. So basically, as soon as he died, they just reinstalled, and his son, Tutankhamun, was too young to rule. They just went back to the old gods and got back to business and making money and doing whatever. And so they tried to erase that guy from history. Carved up, abandoned his capital, defaced all of his statues. In fact, most of what we know about him was a lot of the statues and artwork from that period of time, they just used it as filler blocks. They tore it all down and used it as filler between pylons, like two stone walls. They use a bunch of rubble in the middle to fill it up on some of their temple architecture. And if you excavate that, they just use it as filler. So we actually have there's an entire wing at the Cairo Museum, the National Archaeological Museum in Cairo, Egypt, dedicated to that guy.
So why did they try to erase him? They're just jealous of this dude?
He's considered a heretic because he said none of these gods that you've been worshiping for the last 2,000 years are real. There's only this one god now. And then they were...
so this guy said that all these gods are made up and you guys suck, but actually there's still this one god. So he was almost there. He was almost there.
He was the first monotheist, and it predates Judaism by a century. And I'm quite sure they heard of that. I'm pretty sure
that's
they heard
weird.
Of that monotheistic guy. Right?
Usually religion solves all problems and brings everybody together. Usually it doesn't create all kinds of issues.
Usually it's because no problems at all, right?
It usually doesn't cause any problems. This is weird. This is news.
Yeah, but that was Akhenaten, and that was the rays of the sun disk, which of the god Aten raining down on the royal family, and that was him.
That would have been you back then, Nick, if you were opposing all these guys' taxonomy. You would have been like, hey, they would have been like, dude, fuck this guy's statues up. Get him out of here.
I'm just like, you got to make your case. If you got a case to make, then make your case. But they need to reform the rules for taxonomy so there's a consistent standard.
Yeah, I like your approach, though. It's like a lot of people don't want to voice their opinions, sometimes because, it doesn't align with everybody else. And it's good not to obviously it's when there's things that make sense and you agree with it. But yeah, I think your interpretation and explanation of taxonomy is pretty spot on. It makes sense. I think even for layman's like me and other people, especially if you're new to it or if you're looking at reptile taxonomy and how it changes. And then there's things they had completely wrong. Let's corn snakes. Corn snakes were Elaphae for a long time, totally different genus than other rat snakes. And it's why they're closely related. And then eventually they're yeah, I guess they are pretty close, guys. Everybody was right. They're pantherophytes now. And they were always pantherophytes. And yeah, so the taxonomy is always changing because, like you say, a lot of it's subjective and it's open interpretation. And yeah, it's yeah, what are the parameters to this? You could do DNA testing, but what is the parameters to this DNA testing? And even that doesn't seem like it's that reliable either.
There are trends in everything. Trends in fashion, in music, in whatever. But there's trends in taxonomy that change over time too. There's not just a single definition of a species. There's a couple dozen different species concepts. Which one is the real one? What is a species? A species is a made-up thing what it basically comes down to is that the natural world is so complicated and so diverse and so convoluted that our little primate brains can't even wrap our brain around it in its totality. So we divide it up into little tiny imaginary boxes that we call species to help our little monkey brains get a handle on it. But they are just artificial designations, somewhat arbitrary in a lot of cases, it's a tool for us to help us understand the relationships between these things. And people think of it as, I think a lot of people think about it like, they don't look at it like that. They think of this as like some rigidly well-defined thing. And,
Sure, yeah, and I think you're eye-opening in that case. Like, hey, this stuff isn't, set in stone. It's not really that black and white, and this is, like you say, it's arbitrary and subjective, and there is a science to it. It is trying to classify stuff and understand things, but it is loose. It's loose.
There's the species concept that is most widely used in research now is the phylogenetic species concept, and that plays off of a concept called cladistics.
Ooh.
And cladistics is the never-ending quest for monophyly. Basically, that every lineage, it's a bit complicated, but you end up with not weird, it makes perfect sense, but it seems nonsensical to people unless you really immerse yourself in it. It's like, according to cladistics, we are all fish. You and we are highly evolved land fish.
I've seen that meme where the fish is crawling out and they're like, that fucker should have stayed in.
Clades, you are a member of every clade that all of your ancestors were members of. So at some point, every living thing is a member of one giant clade. And then it gets refined further into finer and finer resolution into smaller and smaller groups. So we are still a fish because we had a fish that was an ancestor. So we are basically highly derived land fish that drive cars and make computers and stuff. But we're still fish. We're also amphibians. We're tetrapods. We're reptiles. We're synapsids. We're also mammals. We're part of the mammal clade, which is also a large part of the synapsid clade, which is part of the reptile clade, which is part of the, it's like an on and on and on and on and on. We're amniotes because that's a huge clade. So we're in that clade. You might be more adequately defined by some more finer definitions enough, but you don't surrender your membership card for all the other groups that your ancestors previously were in as well. So that's why you are an animal, but you're a mammal, but you're still a primate, even though you're a human, and you're still technically sort of a land fish, but you're also a tetrapod, but you're also you're all these things at the same time because you're a member of all these clades, because its clades are nested inside of larger clades, which are nested inside of even larger clades. And so the phylogenetic species concept is what people are in love with, and that is the flavor of the month or the last however many years now. But it's not the only one. Ideally, you don't want paraphyly in your clade. You don't want to have here's an example, depending on philosophically. Within the Python, something I would like to fix is that you have two groups of things in the genus Morelia that shouldn't be in there. You have the green tree python group and the carpet python group that are radically different from each other. They have no business being in the same genera at all. They're not. Keeping them in the same genera makes Morelia as a genus paraphyletic, because these guys are all more closely related to each other, and these guys are more closely related to each other than either group is to each other. That is paraphyletic. So if Morelia is paraphyletic, you need to split that, and the only way you do that is by resurrecting the genus chondropython, which somebody should do. Maybe I'll do it.
That's your same thoughts on blood pythons too.
Yeah, it's like they're obviously don't belong with this other stuff. You can usually tell when things don't belong, can't you? It's like, yeah, these are, you're into hognose snakes, and you mentioned corn snakes. Did you need a taxonomist to tell you a hognose snake was different than a corn snake? No, you can.
No, probably not.
Your eyes tell you that, don't it? It's like yeah, it's pretty obviously a different thing. These are to lump them together, and that's why they split the Asian rat snakes and retained Elaphe for them and Pantherophis for the American former members of Elaphe. Probably because there's rules to what you get to name things. The only way that would make sense, and I'm sure this is what happened, is that you had Asian Elaphe and American Elaphe, but what was the type specimen for the genus Elaphe? It was probably an Asian species. So then if you later on, be it DNA or what have you, decide, okay, these should not be in the same group, this is paraphyletic. Elaphe is paraphyletic because the American Elaphe and the Asian Elaphe are so different that this is paraphyletic. the older name Elafe goes to what was the type specimen for the genus Elafe, and it was probably an Asian species. So therefore, the Asian species would retain Elafe, and you'd regulate a new genus for the American species.
Yeah, and then corn snakes and rat snakes they can hybridize pretty easily. I think the Asian rats are very hard to hybridize with the old worlds are really hard to hybridize with the new worlds.
I just thought of something else that might be relevant to this, but forgive my tangent, but it's hard to imagine a snake crossing the Bering Land Bridge, but there's at least one other instance where that probably may well have happened, and that is Erisine snakes, which we lump in with Erisine snakes, which are their own family of snake that we lump in with boas, because any basal snake that still has the rudiments of a pelvis and pelvic spurs that gives live birth, we call it a boa, even if it's not a true boa. So boas are a family of snakes, but the Ericinae is another family of snakes that we tend to get lumped them in with boas, but they're not really boas. And there are both New World and Old World. There are Asian, African, and North American Ericine snakes. So all of your sand boas throughout Asia, India, all those sand boas are Ericine snakes. Also, your Calabar burrowing python, same thing. It's an Ericine snake. So they range from Africa all the way through Asia. But in North America, you have a couple species of them as well. You've got your rosy boas and your rubber boas are New World Ericine snakes. So at some point, they had to make that crossing. It's like, and was that 30-ish million years ago or 13? When was that? Like there had to have been a point where they had to, because they're not very seaworthy animals.
No.
They're all kind of smallish, live-bearing, smallish, kind of stout, terrestrial little secretive little creatures. They're none of her, they're not not good swimmers or anything. So this is they're all tend to like kind of sandy, arid sort of, or semi-arid. Rubber boas are kind of the exception. They like a lot of like pine forested areas, but they got a lot of those around me.
They can take it really cold too. The rubber boas, man, they're like,
oh yeah,
they can handle very cold climates.
I've got a sweet little spot for them, just like 10 minutes from my house. I can find.
That's cool.
Several. I go out there all the time. This is close enough.
You know what the baby rubber boas eat a lot of?
Lizards.
Yeah, lizard eggs. Yeah, they eat a lot of lizards and lizard eggs.
Yeah, they're little tiny, and you find them like they're born and then they immediately basically go into hibernation and they don't eat their first meal until the next year. Their metabolism is so unimaginably
Hognose do that
slow.
too.
Such slow metabolisms. But yeah, those the New and Old World Ericinae that would follow the same pattern of having like an Asian and New World distribution, or at least relatives. They could run a molecular clock and estimate the divergence time between any Asian species and when the hognose came over. Even that's a fairly common thing to do. Basically, you look at the genomes of the two species on either side of this divide, and you can basically count the number of differences. And if you know that the baseline level of like mutation rate, the mutation occurs at this fairly regular rate, by calculating the percentage of different genes that they possess, you can kind of have a rudimentary estimate of when these populations diverged from each other, when they.
That's pretty accurate.
Ancestor. It's a guess. It's subject to some refinement, but it gets you in the ballpark.
Interesting. Yeah, I never heard of that. That's kind of interesting.
It gets you a close enough window of time to where you start looking at the broad scale climate data, and you start to figure out like, oh, what was going on around that time, and you'll usually find, oh, that's probably how that happened. And you can kind of reconstruct past events many millions of years in the past by doing that.
Let's look at a shorter time frame, because I was talking to you about this one time, and I was like, you know what? I didn't think about that. That's very interesting. That hognose, plains hognose, didn't exist in Montana like 25,000 years ago, because Montana 30,000 years ago was mostly under ice.
There was no Canadian hognose. There was
no Canadian hognose. Yeah,
there's a whole lot of that stuff, and they probably were not getting super close to the edge of it either. They're probably pushed down quite a ways. You might have had some southern Wyoming hognose or something, but you wouldn't have.
Yeah, sure.
You'd have pushed that belt of habitability quite a bit further south, but then it goes back up, and then it comes back down, but it stays down. The icy conditions are the dominant conditions of the last 2.5 million years. It's mostly been ice with brief punctuated periods of time. There is a, but there is a, yeah, like I said, marine isotope stage 5, and when I say MIS 5, that's marine isotope stage 5. What they'll do is they'll take sediment cores in the ocean, and by the dissolved oxygen in those sediment cores, there's different isotopes of oxygen, different versions of oxygen, and these occur at, and they correlate strongly with temperatures. So by looking at 3 things that or mainly like the foraminifera, and basically like little microscopic fossil shells and things from plankton and whatnot that you find in the sediment cores, they correlate very strongly with ocean temperatures, and with the oxygen isotopes in those sediments, you can kind of see warm periods and cold periods, and it works out pretty well. And they use the oxygen isotopes are the main thing. That's why it's marine isotope stage, and they name them based on that. But in the foraminifera and the plankton, that kind of stuff is, sort of proxies for climate as well. But if you go back just 130,000 years ago to the Eemian interglacial, which is 2 interglacial cycles ago before this one, it was noticeably warmer. You're talking 2 degrees centigrade warmer than it is today, which is a lot warmer. So during the Eemian interglacial, a lot of things are happening around the world. Like you have because climate's unusually warm and wet, the warmer it gets, the wetter it gets in most places. So life gets a lot easier for a lot of animals. And so those hognose snakes that get just over the border into Canada now would have probably extended much further at that 130,000 year ago interglacial during the Eemian, because the climate was better. So they would have been able to punch quite a bit further north, because that band of habitability would have moved north with that warmer weather. And then, of course, the ice comes back.
So these ice ages are kind of like a fluctuation, and so you have this. So you're going to have these ranges that are expanding and contracting, and going along with this climate and trying to survive as the climate is changing. The habitat and the terrain and the livability and the conditions, and these animals are adapting and evolving to these frequent stages of these ice ages that you've been, explaining, that have been frequenting for 2.5 million years as just not one single ice age. It's a multitude of them that are, that vary.
Yeah, absolutely. All of these ice ages and glacial advances and retreats are based on a concept that was a Croatian guy named Milankovic figured out what was causing this, and so it's named after him as Milankovic cycles.
Okay, cool.
And it's basically a
John Milankovic.
It's based on a few different metrics, and it's one of those things that it can be calculated fairly precisely, in that it's the Earth's. People think of the Earth's orbit as being like this circular orbit, and the Earth is spinning on its axis at 22 degrees, and everything is like very precision, and it's totally not. The actual reality is the Earth is like rotating, and it's kind of wobbling on its axis, kind of just rolling around like a drunk person around the sun. And the Earth's orbit is not always. It ranges from very, very close to a perfect circle, only very slightly elliptical, to more elliptical. So at various times, the Earth is not a consistent distance from the sun. It's always in the warm enough area, but it can get further away during various periods of time. Also, the Earth's axis is not stable. It changes. The angle of the tilt of the Earth's axis changes over time on predictable cycles, and the axis, there's a precessional rotation of the axis. So the axis changes its orientation as well, and the combination of all 3 of those things is what causes these Milankovic cycle, which is what causes advances in ice and retreating of ice. So what you have is because when you get to a period of time where all these things line up in the least favorable, for us anyway, configuration, it's when it is winter in the northern hemisphere, when the Earth's axis its axial tilt is more extreme, and it's at perihelion, this farthest distance from the sun. So when the Earth's orbit gets more elliptical, and winter occurs in the northern hemisphere at that farther distance from the sun, and the axis is tilted more, you get ice starts creeping in because global temperatures come down, and then all those things reverse, but over time. But it's the combination of those 3 things. It's kind of like the gears in a clock. It's
that's interesting.
You can calculate these things. Then
so it's kind of sequential.
Yes, There are other things though that cause problems with it that can adjust that too. A large one is volcanism. People don't realize like just how much of an effect like a severe volcanic eruption,
Okay. Yeah.
what that can do to the global climate for
Nah, I do
years.
that stuff all the time. It's fine.
It can have a profound effect. There's there's a ton of, even during historical times, it'll be like there's different types of volcanoes. Your garden variety small volcano, is not gonna have much of an effect on global climate for a sustained period of time. But there's this other type of volcano called a caldera volcano, and they're also referred to as super volcanoes. Yellowstone National Park is a super volcano.
Oh
It's a
yeah.
caldera. It's a mantle plume that blows up every once in a while and basically is the most devastating natural thing you could ever imagine.
Oh, I've seen that map, dude. It's scary.
It is, yeah, and there's nothing you can do about it at all.
They
It's like-
need to
it's-
truck in a bunch of dirt and keep piling it up on there.
Wouldn't matter at all. There is nothing. We are too insignificant.
More dirt.
There's nothing you could do to stop something of that magnitude. It's
Move
going
to
happen.
Ohio.
It could be like 150,000 years from now or Tuesday.
I
It's
hope
kind
not
of like-
Tuesday. That'll fuck up my shipping plans.
The United States U.S. Geological Survey keeps a close eye on that, and you can see that mantle plume has built up, and the ground level is heaving up as it's building and refilling that magma chamber for the next eruption. You can see in historical photographs just in the last few hundred years, the landmarks that you can line up like, oh, that the ground is lifting. That is a thing. That doesn't mean it's imminently going to explode. It might
Yeah.
be
Still terrifying.
might be 40,000 years from now. When it does, though, if the United States existed at that point, which is unlikely, it would not exist after that. It would be the end of it. It could quite nicely collapse civilization. But these things happen, and when they do, it affects the global climate for for centuries. So you have these like minor blips. Like if you look at during the Holocene, between the end of the last glacial maximum, which is about 20,000 years ago, you started this warming trend, and that's continued up till today. But you had a couple major climate problems, or things. You had the older Dryas and the younger Dryas, which is basically like temperatures gotten almost back and warmed almost up to where they are now, and then something happens and it plunges down back into basically glacial conditions for like a few hundred years or 1,000 years, but without much transition, like a hard and it just gets cold one day. Not one day, but like in a very small number of years, temperatures collapse back into glacial conditions, ice starts returning, and then it comes back, warms back up. Also, you had two minor things during the warm-up. You had the Little Ice Age and the Medieval Warm Period. You had a weird warm period for a few centuries in the Middle Ages, which is when the Norse settled Greenland and could farm and grow crops in Greenland because Greenland was not totally covered in ice. It was mostly covered in ice, but around in a few spots around the coast, there were a few places where they established and they could grow food because it was allowed. And then it changed because immediately it went from the medieval warm period straight into the Little Ice Age, where not only did the warm temperatures continue to fall, it didn't stop at baseline, it went below. So that's why when you see, famous paintings of like George Washington crossing the Delaware River to go attack the British during the Revolutionary War, there's all this fucking ice in the Delaware River. There's no ice in the Delaware River. Like that's not Little Ice Age. The Little Ice Age did not end until about the American Civil War, about the 1850s, 1860s. So you had prior to that, it was colder than it is now. So you had this warm period and a cold period. These are small fluctuations. So even when it's, in an interglacial, you get these little hiccups.
Well, even in the early 1900s, the Titanic hit an iceberg. And then you go to look at when that occurs, like mid-April. I'm like, why the fuck's there a huge iceberg in mid-April?
Yeah.
And also, they could have just took the boat down a little further, came up like that. I mean, they were supposed to be looking for these icebergs, especially with that guy that says iceberg dead ahead, but he said it too late. So we have that problem.
Big boats don't corner very well.
No, they don't. They should. Here's the thing, Derek. We gotta look out for icebergs. We got this iceberg kid. We gotta look out. Why don't we just take an extra day and go a little further south? It's mid-April. What the fuck is there icebergs this big here doing? Here, let me see.
Classic tale of hubris. It's like you think you're invincible, And then
Yeah, it does happen. That's yeah. You need the
the
humor.
natural world will humble you. But yeah, you don't see a lot of that. You don't hear a lot of ships hitting icebergs in the last 100 years. But
April 14th. I knew it was like mid-April. My
1912.
biggest gripe with this is like, what the fuck is an iceberg doing there? That's terrible. Should have been warmer.
Right. But yeah, no. So there's climate fluctuations in the last 2.5 million years are absolutely the biggest driver of speciation patterns, range alterations for species, because it's like it's not just the okay, this area is now covered in ice, so nothing's going to live there, but the increasing aridity in the places that aren't covered in ice changes the vegetation pattern. If you look at like, I mean, during a glacial period, the areas not covered by ice, forest cover globally decreases and grassland increases. So grassland specialist species do great in ice age in glacial periods. So that's why horses and bison and muskox and elephants, all these things do great because grassland expands. Tree cover decreases because trees require more water. Then you get to an interglacial, it gets warmer, but it also gets wetter. So grasslands contract. And so browsing species that live on plains and eat grass, their populations are going to be under strain during an interglacial period because their preferred biome shrinks. There's still grasslands and there's still forests at all times, but the ratio of forest to grassland, that changes. And you end up with drier grasslands during glacial periods and wetter forests during interglacial periods, like now. So,
yeah, Matt wants to know what's your consensus on climate change.
My consensus on it? It's one of those questions. It's like I used to try to explain it to people, and I just think that people have this bunker mentality now, and you can't really reach anybody. It's like
I'll listen. I'm all ears here. I'm very open-minded.
If you think that the entire scientific community of the world is lying to you, but these oil company executives, they're the only ones telling you the truth. Like, I can't help you. You're kind of a dummy. Like, I don't know what to tell you. It's like there is no debate about anthropogenic climate change. Like, fucking none. None. There's almost nothing in the scientific community that there is more unanimous. Yeah, this is obviously what's going on. 100% of the data shows us what's going on. The only debate in the scientific community about anthropogenic climate change is how fast is it happening, how bad is it going to get, and how fucked are we? That's the only debate. Whether it's happening or not is not a debate at all. No one is having that. This is the thing that politicians and political parties like to make it seem like, oh, there's opinions on both sides. There isn't opinions on both sides. Well, there are opinions. There are no facts on both. The facts are all on one side. We know this is happening. There is no debate that this is happening. How bad will it get? How screwed are we? And how fast is it gonna get?
I think that's what most people want to know. They want to know how bad it is.
The problem with predictions of how bad it's going to get is that climate is really, really complicated. There are a lot of variables that it's hard to really pin down. There are mathematical scenarios where you could warm yourself into an ice age. That's a thing that could totally happen.
I heard that they can change the oceanic currents and it can actually make
what makes Northern Europe livable, and to a lesser extent Canada, is the North Atlantic Conveyor Current, which basically takes warm water off the west coast of Africa and runs it up. If you look at like the UK, where England and the UK is, it's like the middle. It's all of the UK is at the same latitude as Canada, and quite a ways into Canada.
Yeah, right.
It has a pretty mild climate though, doesn't it? It's because of that warm water current. The engine that drives that current is partly salinity. When you dilute and you melt a bunch of polar ice, you dilute the salinity of the ocean, and it can shut down that North Atlantic Conveyor Current, and you'll have ice advance in Europe and make Scandinavia, the UK, become unlivable. And we know that this has happened through natural processes on more than one occasion. This is not like a guess. This has happened.
That's like the 80th reason to move out of the UK. You got another reason to move out of there now.
Other things that could happen. Like, okay, there is a ridiculous amount of methane in the deep ocean and in permafrost in like Siberia and northern Canada. That has been locked away and sequestered because it's permafrost. It's permanently freaking frozen. When you warm that permafrost up and it starts to melt, you find a bunch of cool Ice Age animals and fossils. That's cool. But you also release all this methane, which is a super greenhouse gas. What will that do? The increasing methane content released from melting permafrost causes the Earth to get warmer, which causes a feedback loop, which melts more permafrost and releases more methane, and on and on and on and on. And you could have a runaway effect of that. The problem is, it's just so complicated. You can know that it's happening and you can know that it's bad, but it's really hard to make a prediction as to what's going to happen because these things are so complicated. But yeah, no, it's absolutely happening, and everybody should know that.
Well, with climate, it's one thing I have to cut you off, but with the climate change, the climate's always naturally changing. So some people kind of think that but how much of an impact are we? Like, what % are we changing, and the climate's changing? Do you think has to do with the current events, the climate current?
You should put up
I think it's like 80-20.
It's the Earth should be fighting us and going the other direction into another glacial period.
Right, that sucks. I hate the cold.
And we are warming faster than at any point ever. So from what we've been able to glean, the rate of warming is wholly unprecedented. And guess when the warming started? Yeah, pretty precipitous, pretty definitively at the Industrial Revolution. Basically right then. It's like, oh shit, now we can cut down all these fucking trees and just start burning shit. Like, it starts right then. If you look at, since the Industrial Revolution, all this has happened in this incredibly, even these like minor sort of climate events like the Little Ice Age and the Medieval Warm Period, these things played out over centuries or millennia, not over decades. So the rate that this is happening is utterly and completely unprecedented. It's because it's us. We're the ones doing it.
All right, Nick, who do you want to blame more? Are we going to blame, let's say we're going to pick two countries, China or the United States? Which one? We're kind of intertwined with our...
It's 100% us. It's 100% us.
We're very intertwined with our economy.
China manufactures stuff because we thought it was too expensive. We are addicted to cheap
crap. Right, yes. It's kind of intertwined.
We didn't want to pay Americans what they needed to make a living to make our cheap crap, so we outsourced our cheap crap production to China. So anything that China pumps out in the atmosphere is in the pursuit of making cheap crap for us, plus all the shit we pump out. It's all to satisfy Americans' demand for cheap crap.
Yeah, I get that. How does that affect the Mexican hognose population?
It's like increasing. It is difficult to say as the world gets warmer, and they're talking about like people think, oh, like 2 degrees centigrade difference, like that's no big deal. 2 degrees, like that's a fucking lot. 2 degrees, because when the Earth cools or warms, it's not. Your temperature at the equator really doesn't change that much. It gets more and more extreme the closer you get to the poles. So like if your global average temperature is like 2 degrees centigrade warmer, well, that doesn't sound that bad. It's probably like a quarter or a half a degree at the equator and like 8 degrees at the poles, which melts all the ice, floods all your low-lying areas, causes a bunch of problems. There have been numerous periods of time where there was no ice on Earth.
I heard that. Is warm enough to swim at the North and South Pole. Is that like, well, North Pole, the South Pole is just mostly. I mean, there's ponds, I guess, in Antarctica. Yeah, it's land.
There are still a bunch of lakes in Antarctica.
Yeah, there's still like 2 miles deep.
Yeah.
Do you think there's little fish living under there?
I don't know. That would be difficult. There's definitely microbes.
There's
definitely things. There are definitely life forms in there.
Like little shrimp guys. Probably a little shrimp guy.
As far as getting to multicellular stuff, I would bet there's something. Because everywhere, it's like Jeff Goldblum said, life finds a way, and that is totally true. Things are, because that ice didn't just show up. It just got colder and colder and colder and colder over a long period of time, and things had a chance to adapt to that. So, then you get the pressure, so that's a whole other thing.
People like to put things in boxes, Nick. What's your estimate on our impact, humans' impact on the climate change versus natural climate change? You think we're like 80? You want to give us 80%? We're like impacting a 20% natural climate change. What are you doing? 80-20? 90-10?
No, it's like 95 and 5. And it
Oh,
might
95 and 5?
It might not even be 5.
Right.
This is a human-driven phenomenon. And that's the idea that, like, we've had, like, 5 mass extinction events in Earth's history. There's been minor extinction events as well, where a lot of species went out. But you've had 5 major mass extinction events, and people don't realize that we are literally living in the 6th one. Right now, 2026, we are right smack in the middle of the 6th mass extinction in Earth's history. And it's entirely, we're the ones doing it. The loss of biodiversity because of people, because we've cut down all the forests, we've burned everything, we're fucking up the climate, our impact, because there's no species of vertebrate that's supposed to be 8 billion of us. There's just, and the demands of keeping 8 billion people fed, it's like it's coming at the cost of everything else. I mean, you know, our grandchildren will never see an elephant or a rhinoceros or a giraffe because all those things will be fucking gone. They'll see pictures of them. They will not be able to go see one because there won't be any. Because where are they going to be? There's too many freaking people. And
all right, Nick.
You know,
do we have any optimistic takes? Is there anything that's good? This sounds very bleak right now.
You asked. I guess you did ask.
I mean, we got good stuff.
Takes?
There's still good stuff. Like, you enjoy the. This is lemonade. I thought I bought limeade, but you know, there's still like simple pleasures like that. Things are still going good. And this total wipeout and annihilation that Nick's talking about, that might happen in 10,000 years or 1,000 years.
Oh,
Nick,
no, it's way faster than that. Like, it's
give us the percent. How many years until we're all dead?
Oh, we'll probably never be dead. These scenarios aren't like
that's optimistic.
It's not
I like that.
It's not that humans are going to become extinct. It's that, but civilization as you know it might get pretty shitty.
Right.
Like, if we're not going away, we're really smart and really adaptable. We can fuck things up and we'll find a way to eke out an existence.
Right.
But the standard of living we have and the world that our children and grandchildren will inherit will be diminished. It's, you know, that is more it's more that. And how many species do you lose before you wake up? But you can't get that stuff back once it's gone. And we're, like I said, we're in the middle of if you look at any of the prior mass extinctions, these were not like, it wasn't like, with the exception of the 66 million year old dinosaur killing impact event at the Cretaceous Tertiary impact event, where it literally was kind of like, and a rock hit the earth and boom, all at one time very dramatically. Usually these are things that, well, like the biggest mass extinction of all time was the end Permian mass extinction, and which is like over 90% of all life on Earth died. In the oceans, on land, 90% of everything, plants, everything, 90% of everything died. That took place over a period of a few million years of a slow simmering volcanic eruption in Siberia. The Siberian traps just kept oozing out basalt lava flows and fucking toxic gas that just kept pumping out for over a few million years. That was enough to kill everything.
All right, Nick, with where we're going as a species and all the problems, where do you think ball python breeders are going to be at in 100 years? 1 century from now, ball python breeders. What do you think the market's going to be like? Do they exist? What the fuck is happening?
I don't think you never say never, but I don't
never say never. The ball python market, dude, this is a good time because in 100 years from now, we're dead. Somebody might be around. Somebody's going to be listening to this. They're going to be listening to this. And they're like, Nick Button said ball pythons 100 years from now is going to be dead. Look at us now. And it's like, it's going to be like what Bob Vu says and everybody else. The ball python market's still going.
Yeah, those people are making money by telling you that, though. You should take that with a grain of salt. When the guy that makes his living selling his ball pythons is preaching the gospel of eternal optimism, he's kind of got a reason for doing that, probably, doesn't he?
It's a circle of life. It's a circle of life.
I have no dog in this fight, and I've been around this hobby for a very long time.
Yeah.
And I'll tell you, and the fate of the ball python thing is the same as the fate of the hognose thing. Eventually, what will happen is what has to happen and what's happening now. And it will happen to the hognose at some point as well. These markets are built on everybody pursuing morphs, which are frankly trivial. It's cool because it's new. It's the new cool thing. this combination, this base morph, these are new, therefore they are cool. When they are not new and everyone's got it, it's not that cool anymore, because then you're onto some other thing that is new. Eventually, those markets are based on you're selling most of your snakes, you're selling to people that want to breed them to make more snakes. So your breeders are selling snakes to other breeders who then are breeding them and selling snakes to yet other breeders. Eventually, you exhaust the supply of people that want to breed hognose snakes or ball pythons or corn snakes, and you end up having a market contraction, and then stabilization, where you're primarily selling, the people that are buying are the end user, the guy that just wants to have a pet snake that looks cool.
Yeah.
And that's the point where the average per animal price is a lot lower, but you have stability because you're no longer catering towards a market that's based on entirely on people speculating what's going to be worth and what's hot and what's not. Is this cool looking? Then it's the pet owner. That's when you get to stability. And the
hognose stability is pretty good though. Like I sell a lot of $300, $400, $500, $600 hognose pets. But Nick, you don't hear what I say. When people ask me about breeding hognose for a living, I advise most people not to do it. I was like, if there was like a ton of meat, the market would suck. And then some people are like, the funny thing is, if I tell people you shouldn't do this for a living, or it's really hard that you can't, they're like, well, he can. Well, is he special? And then if I tell people to do it, they'll be like, oh, well, you're just trying to make a sale. You're trying to do this. So it's kind of like a damned if you do, damned if you don't. I mean, the one thing I look at it is like hognose. It's a very strong, very popular market. So generally, even if you invest, like you overinvest, if you stick with it, it's very easy to make your money back because they're such a popular species and they have a good amount of babies. They're pretty cheap to raise and care for. So your profit margins could be pretty high. So you could actually buy like a couple $10,000 hognose and a few $1,000 hognose. If you breed them long enough, even selling babies at $200 each over a period of like 5-7 years, you'll actually make all of your money back. Most people don't think about the compounding of the profits, how fast it works, because I've been overinvested in hognose projects and thought I would never get my money back, and then I couldn't believe that not only did I make all that back, I made like a massive amount more. And I'm not trying to sell people on that, because if you're getting into breeding hognose, that's I think one of the last things to focus on is the money. But it is like living art, and if you want to throw a lot of money at it, like I like to do,
you will end up with, eventually, all these things become corn snakes. Look at corn snakes. Been around for 60, 70 years. People have been breeding corn snakes. There's a bajillion more.
Yeah, but it really didn't get big until like the 90s. Hognose been a big man for like 25 years, and they're still not a corn snake. I've had people call that 10 years ago.
People got to the corn snake market at the point now where the corn snake market is mostly people catering to the end user, the pet owner, primarily. And all things eventually have to get to that point. When that happens, that's happening in the ball python thing now. It will happen in the hognose. I don't know. I'm not saying it's going to be next week, next year, maybe 10 years. At some point, you can't keep selling. It's too easy to make 1 million of them, really. And it's like, and if everybody then buys all those and is also trying to breed them, eventually it just becomes too much. Unless it's something that's difficult to breed and people have a high failure rate.
Yeah, true, yeah.
But it's eventually, it gets to that point. And there's nothing wrong with that. I think people, it's a lot of they get upset because they had unrealistic expectations. They think like, you see this all the time, like get on Facebook Marketplace. I'm always on there looking for car parts or any number of these project cars I'm always working on. And you'll see like somebody has some like wheels and tires for sale for a Mustang or whatever. It doesn't matter. And they're like, I paid $2,000. I'm willing to sacrifice for $1,950. They're like, they have no idea. It's like this idea that things, just because they bought at one price, they think that they're going to be able to sell at that same price. And it's not like that. It's like the supply in the reptile market. It's the only market where it's supply and demand, but the supply self-replicates, sometimes pretty fast.
Sure,
so it's always coming down. And it's like you don't just, and I think people, they get disillusioned with, they bought something and they had this expectation and then it didn't meet their expectation as to what the market conditions, price, demand were, which they could have probably looked at and guessed. And then like, they're all surprised they didn't make, it's not that they can't make money. They can't make their money back, because I don't care if you sold them all as normals, you will always make your money back. They get mad because they don't make as much money as they thought they were going to, as fast as they thought they were going to make it. It's not that, I'll tell a brief story without naming names. the first time I spent big money on a reptile project, and this was in 1999 or 1998, I bought 2.2 Brettles pythons.
Ooh,
$10,000.
I know this story.
$5,000 a pair, 2.2, and 1998, Nick didn't have no $10,000 to throw around. Like that was a lot of money almost 30 years ago. That was the first time I ever went deep. I wanted them so bad, and then the price completely and utterly imploded. When they take 4 years to mature, I had 2 clutches in the incubator, and the price went from $5,000 a pair to $500 a pair. A 90% price collapse between buying my original animals as babies and producing my first babies. It's hard to imagine a scenario where something loses more than 90%.
Yeah, that's crazy.
And I made 100% of my initial $10,000 investment, like a $3,000 profit the very first year, even with a 90% price to up. Because it turns out you're not trying to make all your money back on one fucking egg. I had like freaking like 28 eggs between the 2 clutches. I made all my money back, even at the ridiculously low prices. And then you know what I did the next year? I bred them both again. And then the year after that, I bred them both again. Only it was I ended up making a tremendous amount of money on that. It was a fantastically successful investment. It wasn't what you thought. And I was pissed when the price did that. I was, the sky was falling. But after that happened, I think it's one of the reasons why I've been successful doing this. Like, okay, I got my sea legs under me now. It's like, oh, that was hard to imagine anything going as bad as that. And I still made money. It's like if you stick with it, you're not entitled to any particular amount. Stay the course. You will eventually, you might have to you'll get to make all your money back on 2 babies. You might have to make 20 babies.
Perfect story and example of how breeding goes and how like a lot of people overthink these priority get like, in their head, like, oh, I paid this much and the price came down this much. And you're saying, hey, I produced this many babies and you stuck with it and you end up making a bunch of profit. I think that's where a lot of people like they just don't think about the math, and how fast this stuff adds up. MJ clipped this. MJ, this is one of those ones where you play it and you take the clip and you post it. There you go, MJ.
I didn't get a word in yet with the clip.
Dave wants to be part of the clip, MJ. MJ, make 2 clips. Dave, input.
So, not so much pushback, but like, you talked about, how old the corn snake market is, how long people are working with them. When the palmetto came around, there was still a willingness in that community to go after something that was high end, that was exclusive. And that market held for years. And I remember seeing the females at $4,000 at Daytona year after year. The milk steak market right now for Hondurans, there's that dark project that Kayla has. I saw that priced at $2,500 and people are buying them. So where the ball pythons, there might be more people willing to spend that high amount of money. I feel like almost every species, there's people within it that are willing to spend a little extra money, even if they've done it for a while, if it's different enough.
I'm not saying, I think you might have misunderstood me. I'm not saying that like there won't be anything expensive. It's like the baseline level, the average price for these are mostly going to people that are not going to necessarily breed them. But doesn't mean that people that aren't into them, when something new that's really dramatic comes around, like a palmetto, and then people aren't going to go crazy for it, because of course they are. And it'll be the same thing even in the post ball python bubble economy. Like they will still, if something new crazy thing shows up, people will want it and people will pay good money for it. And with all these things, that will always be the case. The average sort of market dynamic will be one thing, but that doesn't mean that there won't be spikes in interest in new things, because there absolutely will be. The palmetto thing was a bit manipulated, you got to admit. Like actually, I was like carefully orchestrated and manipulated to maintain that value for as long as it was, which it worked.
That's a bit of a conspiracy theory. They release females first.
And only, and then what do? You just freaking, grease the male so that they don't just slow everybody down on purpose. So I got to raise this female for an extra year and I get 1 clutch as opposed to male you can breed to 1,000,000 things.
Yeah. They did that. I mean, it was smart for the guys releasing it and making money. They did do that.
I'm like, you know what? It's not like, this is not like manipulating a market where you're depriving people of food and shelter and basic life necessities. It's a luxury reptile. You're not entitled to a luxury reptile. You're not hurting anybody
This is living
by
art.
refusing to sell them a male snake. No one's life is ruined because it's like, I don't have an ethical problem with it. I make kind of a dick move maybe, but I don't have that big of a problem with that. Like, they played the game well, whatever, with that. And
well, here's the thing. I think, like, where I'm more reptile, you're more reptile related. You put that idea into everything you're working on. There are some people that come in the industry that have a little more business sense than other people, and where we kind of mock what we consider the mismanagement of something was actually managed more as a less hobbyist, more of a business perspective. So I can't really hate them for finding a way to actually come in and work a system.
I got no hate. It's like I said, it's not like they're depriving thirsty people of water or something. It's a luxury snake. It's like you can't really, I can't really fault them. I mean, I have had the opportunity to do those sorts of things, and I have chosen not to. I have had several projects in my own area of influence where I was the only person, the first person with a thing. I've been the first person with a lot of things, proven out a few things, and I didn't do that. I managed those projects to the best of my ability, and because I was seeking longer-term stability, things will come down in price over time. But you can do most people, like you said, they might be good with animals, but they have no business acumen at all, and they make stupid decisions, and they don't think things through, and they don't understand economics, and they shoot themselves in the foot, usually by massively overproducing things. I had the first hypomelanistic Bredl's pythons anybody had. Cost me an absolute mint. And the male was one of those rare, just super horny snakes who would have bred every female you had. And I had, at the time, 14 adult female Bredl's pythons. 14 females. All ready to breed, or proven. 14. So the first year, I bred him to exactly one female. And the second year, I bred him to exactly 2 females. One because I wanted to make hypos that were het for genetic stripe. The third year, I bred him to exactly, you guessed it, 1 female. I didn't breed him I could have bred him to 4 or 5. Did I? No. Because then you'd accelerate the market cycle, the price would go down, and people would lose their ass. They'd pay one price, and then before they could even produce their own offspring, the price would be 80% lower because I just chose not to do that. So I kept production numbers low for as long as I could.
No, that's good. You don't want to overproduce in your own market. I've seen people slash their own throats doing that. And it's like a lot of hognose people have been pretty good about it. There's one guy overseas. He doesn't like to play ball. He likes to play mass produce. But everybody else has kind of been slowing down and be behaving. And even I definitely reduced. I produce a lot because I like genetic diversity and I have so many different projects. But yeah, I mean, what's the point of producing twice the amount or 3 times the amount? Then you have to drop the price so much that you're probably not even really making that much more in a lot of cases. And then you have a lot more overhead and work.
Yeah, I would have, if that would have been a ball, if the carpet python market was the size of the ball python market, I'd have probably made 6 or 8 clutches because there'd have been so many people in that market. It was so big they could have easily absorbed that many offspring for years and years and years. But the carpet market is such a tiny percentage of that. It's so much smaller that me as an individual, I could single-handedly create a new market and also destroy it all within a couple of years just by myself. I got to recognize that it's a small little sandbox I'm playing in, and so I've got to be restrained because if I'm not restrained, I could single-handedly tank the entire carpet market. The only reason it doesn't happen is because I don't breed most of my snakes. Okay, this year I have 17 adult female Bredl's pythons. Just Bredl's pythons. Just that one species. I'm breeding 4 this year. Means 13 of them I'm not even putting a male with. I have, 9 female jungle carpets. I think I've got about a dozen female coastal carpets. In a given year, I typically breed less than a third of the animals I could breed. Most of my collection just sits there and doesn't get bred. I don't even try. Because if I did, I could easily punch out 1,200 carpet pythons in a year.
That's a lot.
I would lose my mind.
Yeah.
I don't have time to take care of that many babies. I couldn't do it justice, so the animals would suffer. And I would single-handedly oversaturate every aspect of the market and tank everything all by myself. So it only works because I got to have restraint and not do that. Last year, I made hypomelanistic striped coastal carpets are actually het for xanthic, or the mutation we call xanthic that isn't really xanthic, but it isn't really recessive either. But that, do you call it anatheristic or xanthic and hognose?
Xanthic.
Okay, it isn't xanthic or anatheristic, but it's whatever. The mutation has different names depending on the species, and all the names are wrong.
It depends. If the animal is more predominantly naturally red, like a corn snake, it'd be considered anatheristic. Then it's something like a ball python, since they're more naturally yellow or gold, it's called xanthic. But the chromatophores that control earthophores and xanthophores are the same chromatophores, and a lot of it's synthesized through diet, these pigmentations. But yeah, I mean, they're interchangeable. It's really the same thing, and a lot of times the mutation doesn't really take away all those pigmentations. There's some remaining yellows or reds.
You tell people that, they get super mad that all these things you've been calling anery and xanthic are actually not recessive. It's an incomplete dominant hypoxanthism.
Well, that's different. Now, the ones I work with are recessive, but you're talking about the carpets. Yeah, this carpet stuff. I have I don't.
Yours aren't recessive either.
Yeah, they are.
Nope, they're not.
Yeah, it is.
I'm telling you.
Well, how is it incomplete dominant? How because
it is never recessive.
It's recessive.
Anything. It's not. It's not.
Well, how explain to me? You just can't say it's not. I can explain. Here's how I'll explain it to you. I'll breed an xanthic to a normal.
I give you like a mountain of evidence, and you got to prove to me that it is, because that would be the thing that would be difficult to prove. What it is this, and this is why people get lost. If you're breeding multi-morph hognose snakes, your data is useless, because you have mixed localities that have different baseline levels of that pigment, the red-yellow spectrum of pigment. That difference in localities means the baseline level of that pigment over in your colony is really variable based on ancestry. Also, when you stack other mutations in there in various forms, you are changing the phenotype so much that it becomes very difficult to detect a slight level change. You need, like, if you had what you're calling xanthic, and it was a wild type, and you bred it to like other wild types that look basically just like it, and you could narrow down the range of variation in that yellow pigment, what you'll find is that the heterozygous animals have a small reduction in yellow pigment. The homozygous animals have a much greater reduction, but it's not a complete elimination, which is why it's hypoxanthism. So what you get is like, okay, if your baseline level of yellow pigment production, let's just make up an imaginary unit. It's yellow pigment units, and the baseline normal has 100 imaginary yellow pigment units. 100. That's its yellow pigment number. Your homozygous xanthic has like 20. 80% of it's gone. 80%. And it looks super xanthic. But not completely. That's why the snows don't look that great when they get older. You see a little bit, or that remainder that's left. When you strip away the other pigment, you can see it. But your heterozygous animals have about a 20% reduction in yellow pigment. But if the baseline level of variation ranges between, like, say, 75 and 100, because it's variable, what you end up in the situation is that the heterozygous animals, for what we're calling xanthic, while it does affect the phenotype, it still falls within the normal range of, imagine a football field with an end zone on each side and 100 yards of playing field in the middle. And the end zones are out of bounds, and everything in that 100 yards in the middle, represents the normal range of variation. Anything that's on the playing field falls within the normal range of variation, and you got to get in the end zone before you get something that's outside of that range of variation. What you find is that the heterozygous for xanthic, they're all on the playing field. They're all within the normal range of variation, so you could say they are normal. However, they're all hanging out on like the 20-yard line near the end zone, but they're not in the end zone, but they're over here. They're all way over here. But they're still within that range of variation. But from a technical point, if the heterozygous state affects the gene product at all, even inconsistently, it is incomplete dominant and not recessive. And I will guarantee you that the baseline level of pigment in your heterozygous xanthics is lower. It might be slightly lower, maybe just this much lower, but it's reducing it because it does it in literally
it has to be phenotypically like distinguishable, though. Like, you're saying 80%, you're giving like an example that, like, hey, the head xanthics are maybe like 20% change. Meanwhile, the full ones are like close to 100%.
It's not, though. When you look at it, looks like it's 100% when they're babies.
But I said close to 100%, not 100%, because I line breed really high red face stuff into my xanthics. So I have a lot of xanthics that show a little bit of pink. I try to make my snows really high pink. So obviously there's Earthivores and Xanthivores coming through. Doesn't matter which.
The remainder that's left over after you remove 80% of it, that 20% that's left, you're amping that up. So you're kind of pulling in the opposite direction of the mutation. Yeah. I've done that with stuff that's sitting behind me. I've made super hypomelanistic animals that are super red, but they're also exanthic. And you get the same sort of a thing where you end up like a silvery gray baby that looks super faded, but then after a few sheds, it starts getting weird, like orangey, yellowy highlights on an exanthic looking thing with blue eyes, and it's weird.
Right. Yeah, there's certain areas where the more of those Xanthivores and Earthivores show through. All right, do you want me to explain to you how you're wrong?
I'm not wrong, but you could try.
Yeah, I can explain to you how you're wrong. Okay. The difference between an incomplete dominant and recessive mutation. Recessive mutation is masked, obviously, as you know, by another wild type allele. With the incomplete dominant, it's partially masked, but to a degree, it's definitely subjective how much it shows through. A good example, like you see with the ones are like, let's say a red flower is an incomplete dominant, but the red flower is the homozygous, and then a white flower is the wild type. And you make the incomplete dominant, and so let's say it's a very, very faint pink. Well, that one copy of this incomplete dominant red mutation is vaguely showing through. Now, I can make het exanthic / het anarthristic hognose snakes and even pos hets. There's no distinguishable difference between my pos hets where I make 50%ers and the other ones in the clutch. Now, you're saying like I have all these other mixed genes. You're kind of like extrapolating ball pythons. My hognose aren't as genetically, complex, where there's all these stacked mutations. I stack polys. I stack, certain mutations, but I do remember working with exanthic hognose when they were pretty much just in wild type animals. A lot of those animals did kind of err on the grayish or brownish side, but I'd say that's mainly just because they were that locale. When I made my 50% pos hets, there's like, anytime I've done it, there is no distinguishable characteristic with my pos hets, with individual babies. There's definitely, I couldn't find any key characteristic to pick them out. Now you're saying it could be so minute, like you're saying, like, let's say like a smaller percent, but it would have to be down to a fraction of like a minimal 1%. But with that, you could almost argue a lot of recessives aren't actually recessive because there is a little bit of a change, but it's so minor you can't really pick it up with your eye.
They're not. Look at ball pythons. These people are still talking about piebalds being recessive. It's like, also, piebald is never recessive. I don't fucking care. There is no such thing as a recessive pied ever in anything. Show me one. You can.
The other thing is too. You gotta remember, Nick. This is a lot like taxonomy. These rules and these
there are hard rules for this. What the difference is?
No, there isn't. There isn't. If you look at these, there's not hard rules.
There is, and the hard rule is just this: if the presence of a single allele affects the gene product at all, and no matter how minute, it is incomplete dominant. That is a hard and fast rule. What you're wavering on is our ability and how good your eyes, my eyes, or whoever's eyes are to pick out that difference is irrelevant to whether there's a difference. It's like you might have a hard time seeing it. That doesn't make it recessive. It can be, there are a lot of these things that are functionally recessive, but technically, I proved one out. My Stonewash Brettles gene, that is everybody thinks it's recessive. And honestly, I let people think it's recessive because it's so difficult to explain this. It's a piebald gene. It's a permanently super low white piebald gene in Brettles. They are literally, but if I called it a piebald Brettles, people think it should look like a ball python, and it's not that type of piebald. Technically, it's a piebald gene. If you look at the heterozygous animals that are just wild type, nothing else at play, they tend to be a little bit lighter and a little bit brighter with a little bit less black pigment, but they are all well within the goalposts. They are always within, so you end up with these things like, if you raise them through like 3 sheds, you'd start to get a sneaking suspicion which ones were likely to prove out if they were possible hets. But you would never want to put your reputation on the line and sell them as such, as hets, because it's not 100%, but they tend to hang out on the 20-yard line in that analogy. But it's not always consistent. I've seen some very dark ones. With the piebald ball pythons, which are clearly incomplete dominant, I have personally produced heterozygous or piebald ball pythons that had absolutely no visual indicators they were hets at all. Usually, 90% of the time, you can tell it when you see it. But every once there's that 1 in 10 that you can't tell. It's still incomplete dominant.
Well,
It's still incomplete dominant.
the incomplete dominant, you know, basically it the one rule of it, it has to have a phenotypic. If you're going by Mendelian, like genetics, like descriptions, even in the written, even the visual description, it shows that one allele, yeah, it has some observable, measurable difference. You know, that's even like the guys that are. I mean, again, this stuff is subjective because look at like what like people consider what codominance is. So, like codominance is two dominant mutations existing at one time, and they're not like superseding one another. It's kind of like the black and orange cat. But the reason black and orange cats look the way they are is because they're X chromosomal linked genes, and that's why you get these partial black and partial orange ones. And meanwhile, they'll adhere to that definition when you're crossing incomplete dominant, you know, ball pythons. There's no true codominant one because it doesn't meet this very, very precise phenotypic description. Well, and it's like, well, now it's like there's all kinds of different incomplete dominant mutations, and they interact with, you know, the animal in different ways.
There's such a thing as a codominant mutation because codominance isn't even a mode of inheritance.
No, it's
just like
it
describes the
it means co-2 and two dominant traits.
It shows it's the relationship between two genes.
Yes.
Not how either gene is inherited. It's not a.
No, it's not inherited. No. It's not in how it's inherited. It's in how the phenotypic.
How they react with each other.
How they react with one another.
It's not how they're inherited.
It's not in how they're inherited. It's only in how that's a description of something that is in science, you know, or in genetic literature that is only determined based on like the phenotype, and it's this very stringent rule, and it's ridiculous.
Phenotype, I mean, it has to be. I've argued the xanthic thing with a lot of people that like people get in this like, nope, this is what I was told, I'm sticking with it. And
it's not because I was told, dude. I'm not one of those people. If I see something different, I called it out with caramel, hypo, and frost in hognose snakes. Even with like I don't know, there's probably some other examples. Well, actually, zero and stinger and fat tails. My dad kept saying it was like an incomplete dominant. I says polygenic all the way for sure. I'm definitely not, dude. If I could find anything, I produce a lot of het xanthic hognose snakes. There's not one distinction. You said that to me about the leucistic hognose too, and you cannot pick out het leucistic hognose. You cannot.
I bet you can.
Sometimes you're going to, because if you make fucking enough and you pick it, that'd be saying like I bet you I can win at blackjack all the time. Yeah, you're gonna win probably 50% of the time if you play by the fucking rules.
Let's this is a thought exercise. Let's just use Occam's razor. What is more likely? What's the more parsimonious or likely explanation? That leucism and xanthism are incomplete dominant in literally fucking everything else, but in hognose are special and it's recessive. It's incomplete dominant in literally, as far as the eye can see, in every other species, but the hognose are the exception. That is less likely that it's just so subtle you can't see it.
Well, you're comparing mostly just like, I mean, it is ridiculous, like Boida versus Colubrids. But, I mean, you're also like, I pick out a lot of stuff, man. There isn't like anything ever unique. But you're saying if it's such a small fraction that nobody can even detect it, it's still incomplete dominant. But it must be there because you've seen it in other species.
It's technically going to be incomplete dominant, but it would be functionally recessive in terms of how you do business and how people are going to treat it. If it's so subtle that you can't hardly tell from looking at it, like it's like then it's functionally.
That hardly you can't.
Functionally, it's like I don't know. I'm not going to throw in the towel on that one because I'm not
throwing in the towel on this one. I've been breeding hognose, and here's the thing: if I would have observed something different, you know what I would have been doing? I would have been making some cool, badass, incomplete dominant, you know, het xanthic hognose combos, you know, because it's going to have some type of, even if it's a minor interaction, like, you know, I would. At some point, I think I would like pick up on, especially since I picked up on Arctics and other stuff that are very, very obscure.
What I'm saying is like when you make a clutch and they're het xanthic and whatever else, they don't all look the same, do they? They're going to be lighter ones. There's going to be darker ones. There's going to be
there's all kinds of variety because of polygenics.
Yes. What I'm saying is that if you were to take the ones that had the least amount of yellow pigment, they would correlate. They would be more likely to prove to be a het xanthic than the ones with the more bright pigment. That there would be a correlation if you had enough data and you raised up what are the least saturated color animals. They're going to prove out that they're going to be better than 50-50. If they're 50% possible hets, I'll guarantee you that if you held back all the you bred them all, that the ones that were brighter colored would have would be less than 50% proven out. And
here's the thing. Now, let's say if I pick out the lighter ones and they do prove, let's say it's 55%. You think that proves it as an incomplete?
Lighter's the wrong word, because lighter would be relating to melanin. We're talking about like the yellow/red spectrum of pigment.
Yeah, gotcha. Less yellow, red pigment.
The uglier ones are going to prove out to be het xanthic more often than the brighter, the prettier ones. And it might be that it's 55-45. It doesn't have to be, but if it's anything at all, it is technically incomplete dominance. Even if it's practically pointless and it's just a thought exercise, and it doesn't have any bearing on anything, and no one else can even see it, it's still doing something.
I can kind of see your point here, because like anytime there's a recessive, like a heterozygous, that there usually is some type of like interaction, but sometimes it could be other commonly shared alleles. Like I made het Swiss chocolates, and the het Swiss chocolates, especially the anacondas, have very bizarre bellies. But this is like, and it's like very atypical for an anaconda to have a belly like some of these het Swiss chocolate anacondas do. But I also have sometimes I get some really mild connecting a neck pattern on the het Swiss stuff. And I had some possets that had those, and I bred 3 that had these really distinct features, and the one was even a 66, and none of them proved out. So, but they still had that weird interaction. So what I'm thinking is, since they're related, there's an allele that's causing this kind of interaction that's neighboring or related.
Yeah, or it's just like, okay, well, the ancestry of this snake, there are polygenic characters that are at play in those.
These are really weird characteristics, though. They're not like typical. They have to be linked to that actual recessive, which is very bizarre.
Well, that speaks to genes are not inherited necessarily onesies, twosies. Oh, just like, here's this gene, and we're just going to clip it out with a neat pair of scissors and then fucking move it over here. It's not, you're getting chunks of genetic material inherited. And so it might be that it's not strictly always going to travel with that recessive mutation, but it's near enough to where it's likely going to travel with it most of the time, but could eventually be separated.
There you go. I'm glad you agreed. That's what happens with het xanthic, het piebald ball pythons. That's why they're not incomplete dominant. Thanks for answering your own question.
That's not at all it at all.
It is. That's why you can make a bunch of het pieds. I know people that are like, oh, it has the het pied marker, and they raise it up and they breed it, and they go, oh, no pieds. Well, then how the fuck does it have the marker without being that? You just answered your own question. Also. Boom, recessive. Jeff wins.
I don't think that's how that works. I don't think that's how we. All
right, we can do it. Here's the thing: Nick is smarter than me. He's a very educated guy. Put W's in the chat if you think I won. L's in the chat if you think Nick won.
I'm the guy you bring on to have unpopular opinions that people are going to like.
That's right. This is pretty fun. I like this.
People are attached to their dogma, and even if you prove to them that it's like,
we got one W.
It's not this. It doesn't matter. It's like people are just going to stick with it. It's like we call things by the wrong names. We call things by it's just after the wrong. It's like we just do this.
I agree.
How many people in the hobby still use the term codom? That was never a correct term.
No, it's never a correct term.
It was never right. But almost 30 years later, some people are still just attached to that codom. It's like, what are you doing? It's not that difficult to say incomplete dominant.
We're trying. We're trying. Okay.
I think this is.
We gotta make it fun for the people, Nick. That's why co-dominant sounds cool. It sounds cool as shit. Incomplete sounds like it's not complete. Sounds fucked up.
I will admit that codom does roll off the tongue better. It's wrong, but it does sound better. It's easier. Like if I could switch those definitions around in a matter, I probably would. I like it better, but it's wrong. It's like, and I don't think it's that hard to. I just think like there's a lot of people in the hobby that like. They have this like surface level understanding of these things, and a lot of that comes with a lot of misconceptions. And I don't think it's that hard to like get on the right track with some of this.
I know.
Take it to the next, like not even the next level of understanding. The next like this much, just this level, just above, and under a more complete understanding of these phenomena, because, well, like what you were talking about, these other characteristics that sometimes travel with something, but sometimes don't always travel with it, like that sort of thing. You see that a lot.
Oh, you do see it a lot. Yeah, and it makes you think recessive's incomplete dominant for some reason.
It's because it's incomplete dominant. Like, it's always incomplete. Pieds are always incomplete
I think your theory is incomplete. once you think about it a little longer, I mean, just re-listen to this one. You're going to be like, your face is going to go pale as you realize high school dropout Jeff is right.
I will say one thing, like your level of formal education does not dictate how smart you are or how much you know about a thing. If you are passionate about a subject and you want to know, you will learn because you want to learn. You want that information. You seek that out. Having some degree and some arbitrary initials after your name because you finished a certain course of study does not mean you necessarily learned a whole hell of a lot. And it's like you should never... Don't diminish yourself because you might be, I don't know if you actually are a high school dropout or not, but that would have, even if you were.
I just think it's funny.
No bearing on how much you know about hognose snakes.
No, it doesn't. I think being dropping out of high school made me smarter because I just educate myself and I had more of an advantage, actually.
They're not giving out PhDs in hognose snakes. There's not a hognose PhD. Like, it's not, like, if you want to know, you can learn. And so there's no, I hate when people, like, you run into that sometimes with academics and everything. It's like, yeah, it's achieving whatever formal level of education, that's cool, but it doesn't necessarily mean that somebody who doesn't have that doesn't also understand what you're talking about and can't contribute to scientific inquiry.
Yeah, of course. I mean, yeah, that's the thing. I mean, it's if you put a... Yeah.
Can I tell you a ball python genetics story that'll make you happy?
Okay.
Oh, great.
So,
hear this one.
When the paint project started, it was considered
great.
dominant. And then we all got together about 5 years ago, and now it's recessive.
So what, the evidence it was incomplete dominant went away?
Well,
or
it was, people were not picking out the markers like they thought they could because it was like an alien head and like a little bit of granite. But there was some inconsistent breeding soon after the project came out where people were breeding two together that were supposed to be paints to make super paints. But again, when you started putting other genes in there, it became a little too hidden for us to pick out. So we started calling it recessive, and that's the way it's been ever since.
Nick, how do you explain that? All right. So you get the marker, the incomplete dominant marker for this supposed recessive trait that idiot Jeff got wrong. All right. Then super smart Nick found out this wasn't complete dominant because of his marker. But now this one that has the marker doesn't have that gene. Well, how can it have this, like, you know, this subtle, like, or this phenotype? How can this animal have this subtle phenotype that's supposed to be a marker, but it doesn't carry the gene? So it's not like, let's say, in the case of a het pied, it turns out not to be het pied.
If you have severed the two, well, there's two things.
You can't sever the two because it's one gene that's doing it. It cannot be severed.
Is doing it, you can't sever it. If you can sever it, by definition, it is a separate gene. However, and there's a massive caveat you're skipping over. Some of this stuff, you can, like, the little train tracks on the back, like, last little bit of the belly of a freaking pied. I've seen a bunch of animals that weren't wild caught ones that weren't het pied at all. That can occur naturally. Also, convergence is a thing. You can have in a ball python, oh, this little alien head, this little hook in the pattern, that kind of shit happens naturally.
Yeah.
Does it always happen with some consistency or great regularity if it's part of that gene? That's what you're looking for.
I'll give you one, though.
If a couple hets randomly had this pattern anomaly, but it's not something you see with any consistency, it's probably not that.
But I'll give you an example, like with the het Swiss chocolate hognose, especially the anaconda ones with this very, very unusual belly. Like, again, I've produced thousands of hogs. I've never seen a belly like that with these het Swiss. So I was pretty certain I could pull out the het Swiss. And so I did this little experiment. And there was one guy already, he's like, you're an idiot. You can't, well, he didn't say that. But I like to, because that's funny. But he didn't actually say that. But he's like, it's just, I think it's a recessive. And I'm like, yeah, it's like, but some of these het Swiss are very unusual. As I produced thousands of cons, never seen this. And then until I raised up some of these ones that have these really strong markers, and he turned out not to be het. So I'm like, okay, well, what's causing that isn't the actual mutation. Therefore, the whole theory's gone. You're done. We got two W's in the chat. We got no L's or N's. You do L or N for Nick or W for Jeff. We got two W's. I gave myself a W too, so we have three. We have three actually.
I think your audience might be. They tune in to hear you talk. They might be slightly.
I didn't talk that much this time.
Might be possible. They might be biased.
Well,
I get it. If I win, it's biased.
Are slow to.
Dave.
People tend to double down on what they've already believed rather than accept. People.
I tried. I even gave you an example of how I tried to actually be on your side. I was testing my het Swiss chocolate stuff, And I think you're biased now. You're like, I'm telling you this information. Hey, I did this. And you're like, fuck you, Jeff. I don't care.
That is not.
This guy says he hates me and he still gave me a W. I believe that because I was making comments to this guy earlier about ball pythons. This guy does not like me and he still gave me a W.
I can't speak to Swiss. I don't know what a Swiss chocolate even is. So I don't have enough information to.
It's a recessive hypermelanistic mutation that you're going to think is incomplete dominant because you don't like me.
And hypermelanistic mutations are almost always, not always, but are mostly incomplete dominant.
They usually are. They usually are incomplete dominant.
Not always. There are exceptions to that, but they often are. That is, but I don't know enough about it, so I would just be talking out of my ass. If I don't know anything about it, I shouldn't talk about the mutation. I don't know.
I'm telling you, dude. I'm telling you. I tried. I tried. I even marked it as my toffee bells. I still have it in my room. I marked it as my visual hats, and it didn't work out. And there's some of the strongest characteristic ones, which I was like very, very certain. I was surprised. I was like, this one's got to be hat. And it was even a 66. So just statistically, I was very high advantage, 2/3. And it turned out not to be. I couldn't believe it. 2 big clutches, too. And then this year, another clutch. I did the same pairing. No Swiss out of like 40 fucking babies. So here's the comment here. Nah, I hate Jeff. Still win. Thanks, Matt. T, you got to love your haters. Love your haters, guys. Keep on hating, Matt. Appreciate you. All right.
That's I've argued this for a long time. This is not my first rodeo, and it's always the same. People are just like, "Oh no,
this is different. You've met your match. This is very different." I'm giving you Crystal. This is my girlfriend. She's biased. Those het Swiss, I have them all marked in there. Remember that? As I was pointing out, I was like, "This is a het Swiss." Crystal just be like, "Okay," and then I didn't breed it, and I didn't get any Swiss. And I was like, "Dude, these markers are strong as fuck."
I've made no claims about the Swiss because I don't understand it. So, or I was talking about exanthic and anarthristic being none of those.
All right, now you're deviating to win the argument again. Now, I'm just saying, I'm extrapolating the same stuff with the head exanthic stuff.
I can't argue your results with the Swiss stuff because I don't even know what that is really. So I would be arguing from a position of ignorance, and that's always a bad place to be.
All right.
But the exanthic stuff I understand very, very well.
All right, but the piebald ball python. And then, but you even said the hypermelanistic is usually incomplete dominance. It's always incomplete dominance.
It's not always, but it's very often. There are those exceptions in other species where you will see melanistic type mutations that appear to be recessive, but it's very often, it is typically incomplete dominant. Basically, you can look at 2 different types of mutations, and it doesn't matter what the species is. You have pigment distribution mutations. In those animals, the animal can make all the pigments properly, and the mutation boogers up where the pigment goes and how much of the pigment goes where it goes. And the other type of mutations are pigment synthesis mutations. These are mutations that block the proper production of the pigment itself. And what you find is that pigment synthesis mutations are virtually always recessive, and pigment distribution mutations are overwhelmingly incomplete dominant. There are exceptions. Always, but generally speaking, they almost always fall into that. With hypomelanism, there's 2 different types of hypomelanism. There's a recessive type, and there's an incomplete dominant type. One is a pigment synthesis hypo, which we tend to call T-positive albino now because it's the sexier name.
Yeah, sexy.
We've rebranded everything that used to be that was a hypo, and then we rebranded because it does. I'll admit it does sound way sexier. T plus albino, right? So we've rebranded that, and the other type is like the hypo you get in Brettles pythons, coastal carpets, boa constrictors. It's a pigment distribution type. They can make black pigment just fine, but the mutation blocks the distribution of it. That type is always incomplete dominant. So broadly, you can put them in these 2 camps.
That's kind of why you think leucism is always incomplete dominant too, because that's one that it prevents the pigment to be synthesized. They found all leucistics have the same kind of genetic defect. It's called a melanocyte-inducing transcription factor defect. And it doesn't allow a lot of it allows for only a limited amount of pigment to be essentially synthesized, but it's not enough to actually populate. So it just doesn't populate. But it still gets pigment in the eyes because the pigment in the eye actually comes from a different pigment during the embryonic development during the.
So you get these animals where this process of pigmentation is supposed to have a defined start and stop point. And if it goes through all these various intermediate stages represented by different genes, and ultimately you end up with a properly pigmented animal, The animals we call leucistics, these mutations are just, and there's different genes you can break.
Yeah, it's different levels of it.
But they all basically break the process really super early on, where hardly any pigment is synthesized or distributed. It just shuts it down almost immediately. You end up with a default to a white or very nearly.
Yeah, like ivory ball python or something like that, or super fire.
But you've got, look at the ball pythons. There's just so many morphs. They're always the best example because people are familiar with them. And you have whole complexes of this. You've got 4 complexes of leucistic ball python mutations. You've got a blue-eyed complex, the black-eyed complex, you've got the yellow belly complex, and you've got the dead white snake complex, which is your spider, your woma, your hidden gene woma, your champagne. They make the dead white snakes. Then you got your yellow belly. They're all 4 separate, but they'll all interact with each other if you put them together. You won't make a white snake necessarily, but you'll get a synergistic sort of epistatic reaction because you're breaking that process of pigmentation. You're breaking the 2 different links in the same chain, and you get predictably weird results. It's why if you make a spider pied, because pied is related to...
Yeah, right. They're always high white.
Yeah, because pied, basically, if you look at the easiest way to explain this, the process...
Look at the lesser pieds.
Makes perfect sense, though. If you look at the black snake ball pythons with a solid black phenotype, your super cineas, super black pastels, that kind of stuff, pieds, and then your white snakes, it's a spectrum of where you break that. It's basically, imagine a light switch on a wall that's controlled by genes. You flick the switch on, pigment starts going out. When the animal's properly pigmented, you shut the switch off. Animal's properly pigmented. Leucistic, you just basically just click, click, and shut the light off. White snake. A piebald snake, you let it get about halfway, and somewhere in the middle, you shut the switch off early. Animal's half pigmented. Your melanistic snakes go past the point. It should have stopped here. You should have turned the switch off. A gene breaks the switch, and it just keeps sending more and more pigment out, and the animal fills in, paints over the top of itself, and ends up with a black snake. All of these are breaking the pigment distribution pathway at different stages of the process. So when you combine any 2 of them, you get synergistic sort of what are called epistatic reactions. So if you make a Mojave ball python that is het for pied, that's just het for pied, that recessive pied.
Yeah.
What does your Mojave that's het pied look like? Oh, it's totally striped every fucking time.
Is that true, Dave?
Yep.
Made a ton of them. Striping. The leopard Mojave was always striped, though, when you're talking about those early het pieds.
Yep. The cinnamons that are het pied, striped. Shocker.
Every time.
I mean, they're going to get, sometimes you get really crazy nice stuff, and sometimes, it changes. It's obvious. It's a predictable reaction. If you mix a pied with any of that stuff, if you make a pied that's a yellow belly pied, a fire pied, any of that stuff, it pulls it towards high white. It makes the pied ends up being higher white because the presence, a Mojave pied is 90% white.
What you would need to do.
No, that's wrong. The Mojave pied has more pattern, and the yellow belly pied is always pretty heavily patterned.
That is true. Yeah, I do know that. The pumpkin pieds have heavy pattern. The Mojave pieds are pretty reduced. And the funny thing is, lesser pieds are almost always all white.
The lesser pieds end up with being the presence of any of those other alleles pulls the pied towards higher white. Doesn't mean they're always super duper all white like a spider pied, but it pulls it that direction because you've broken another link in that same chain of offense and it causes system failure, and you end up with white areas, so it pulls it in that direction.
Another random one, the spot nose pied is a all white pied or a dot on the end of the tail or in the last small area. But
that's a weird. But it's spot nose is going to be it's the one of the few other neurologically impaired snakes, which implies that it is related to the dead white snake complex.
Yeah, we call it the wobble complex. We're not that.
Yes,
dead white snake one's a new descriptive
If it is related,
name.
If it is related, okay, well, champagne pied, all white snake. Spider pied, pretty much all white snake. Well, all this other stuff, super high white or all white. Well, the one other snake that's got a wobble like that, all white pied. Figure it's because it's related to that other stuff. It's not. I mean, these sort of interactions you see across all species. And there will be exceptions. You might find the occasional enchi pied that's not particularly, that has a reasonable amount of white on it, but the general trend line is clear. Those two things pull it away from being white.
is spot nose allelic with spider? So he says, Matt says spot nose.
I don't know if it's ever been proven to be allelic with spider. I don't know. I just think
Okay.
like, why would on earth would you do that? Like, is your goal to make the most fucked up ball python you could? I'm gonna breed this jacked up spider to this other gene that has the same problem. Why would you do that? Like, why on earth would you like try to stacking genes that are fucked up for the same reason is going to have exactly the effect you want? So it's like, I just think it's like no one would really. Do we know if they're allelic? Has anybody ever tried to figure that out? It seems like it would just.
I'm not sure. The one thing I think is very interesting, Nick, because like usually allelic traits, because they're a mutation of the same allele. A lot of times they have kind of some similarities, but look at like Enchi and Cinnamon. They're allelic, but they're very different. And if you make an Enchi Cinnamon, they look like Enchi and Cinnamon. It doesn't make some type of. I mean, you can. I don't know. It's subjective to say epistatic, like. Like effect, but they're just kind of like, it looks like a combo, like they're different mutations. Like when you put them together, it's like, oh, it looks like a cinnamon.
They are different. They just occupy. They are totally different.
They are exactly. Yeah,
kind
right.
of the opposite ends of things. They're kind of like. Go ahead.
Oh, thank you. So I looked up the allele. I knew most of it, but they have added a little more to it. But again, I usually call it the wobble complex. But spot nose, spider. Champagne, blackhead, chocolate, cypress, hidden gene Wuma, sable, Wuma, and Wookie.
Those are all allelic.
Those are all the same allele. It's getting real big.
Yeah. So that means the same exact locus, the same exact allele. It's just they're just different types of mutations of that allele.
Was chocolate on that list?
Yeah, chocolate. Yeah, chocolate.
Chocolate and sable were proven to be allelic years ago.
Is allelic. They could put that on the list. Yeah, they got most of them though.
Yeah, stacking that stuff together is the fool's errand. Like, why would you do that? Like, it's going to do exactly what it does. Exactly what you think it's going to do. Make it.
Well, we didn't know until we knew. But
I'm saying once you know, you know.
Yeah, once you know, you know. But
I don't think you even need. In some cases, I don't think you needed to. I don't think you needed to breed a champagne to a spider to know it was going to be a train wreck. Like that, they're allelic and it makes it dead white. So you could reasonably predict that was going to be the outcome.
I just remember that, but we only had a few options back then. We were taking chances, man. We were pioneers in the hobby.
I know. Like, I might have done it myself. I don't know. I mean, I just remember on the old World of Ball Pythons website, there was the picture of the first guy to make a. Are you talking about the GHI Pied? No, it was a spot nose pied, or it was a spot nose. What the heck? It was a spot nose spider. And it looked like it was trying to drill a hole in a wooden countertop with its head. It was like, it's like just, look at it was just trying to like burrow into a piece of wood with its head at a weird angle. It's like, that's obviously a disaster. Like, why would you, like, you didn't, I would not have done that breeding because you could have just known, yeah, that's going to go badly. I don't even, there are.
A couple fun things about us, like just trying to figure it out. When they bred the spider to the blackhead, it made a normal-looking snake with a degree of wobble, I believe. So I
thought the wobble was mostly gone.
It's like the worst of both worlds. Like, why would you, like, that's a lot. It's like, I want to make a normal ball python that's mildly handicapped with a lot of extra steps. Like, why would you do that? Like I get that, like, if you didn't know, because some of these things, you would not expect that to be the case. And some
you wouldn't.
Are like, oh, wow, that's quite surprising. And there's another, like, in boa constrictors, hypomelanistic, the pigment distribution hypomelanism, and is allelic with motley, which is homozygous lethal.
That's weird.
Yeah, also, one is a melanistic mutation and one's a hypo. They're opposite ends of the same spectrum. One gene.
There's so many alleles.
Opposite ends of the spectrum.
What are the odds that they keep getting mutations? I think that really says something because these animals have thousands, tens of thousands of alleles, and what are the chances these mutations, I guess the mutations that affect color happen to be the same code a lot of times. Because those are the mutations, like, if they do happen, it does affect pigmentation code, which the reptile hobby likes.
Of all those genes, we're only looking for the ones that affect color and pattern.
Exactly.
And
but it's funny because you kind of find
that affect color and pattern, the genes that are lethal and just kill the embryo early in development, you don't even know about. So you're left with the ones that affect this smaller group of genes and also doesn't kill the embryo. And then, which is why you see the same exact mutations over and over and over and over and over again. Why you got a Lucy hogs, and there's a million Lucy balls, leucism and everything. Why there's these, what is a motley boa if it's not, it's like it's a incomplete dominant gene that's really dark, and the homozygous form is an all-black snake that fucks up its skeletal development. Where have we seen that before? It's not totally lethal in ball pythons, and it is ultimately lethal in motley boas, but it's the same sort of a thing. You see this over and over and over again. The same... all right, the black-eyed leucistic in ball pythons also occurs in like 5 other species. The identical mutation occurs in Amazon tree boas, for example. It's the same thing. And in boa constrictors, same thing. It's like you see the same mutations over and over and over again. The zebra morph in jungle carpet pythons is identical. I mean, fucking identical with same defects and everything as the batik morph in blood pythons. You see the spider gene has popped up about a half a dozen times. There is no difference between a jaguar carpet python, a spider ball, a scoria boa. It's all the same shit. It's all incomplete dominant, freaking pale-eyed, reduced dorsal pattern, pale ventral surface, and girked out with a dead white superform. That's all. It's the same thing. And you see it over and over and over again. So
all right.
We shouldn't be surprised.
Once Elisa wants to know what you think about the shed testing companies that are starting up in the reptile hobby. Are you excited about the shed testing companies that are starting up in the reptile hobby? Excited for that, man.
I'll just be honest. No. Because, and I say that, and it pains me to say that, because I've known Ben Morrill since the late 90s. I've known that guy he's a super nice dude. And Sean, the other guy that helped get that company off the ground, I've stayed at Sean's house. I've known those guys since the late 90s. Great dudes. So I wish them nothing but the best. It's not that. But there is an effect that this has on markets. And it's not good for the market. It's good for the individual in the short term. It's terrible for the market in the long term. Because basically, what happened the last time the ball python market went in the crapper? Oh man, these codoms lose value too fast. I'm going to invest in recessives because it takes longer to make and they're harder to make. What did shed testing do? It made all the recessives codom.
Yeah, basically, yeah, you could identify them. Yep.
You could get a single male you could get a couple of male possible hets for a nickel and make an army of the thing by testing every step of the way, and you could get there with minimal investment.
Do you think it's accurate? How accurate do you think it is, the shed testing?
I've heard of this problem or that problem, but some of these things are complicated, especially when you have like gene complexes where there's, well, look at the locus of the yellow belly gene in ball pythons occurs. There's like 7 things that occur there. They're all some flavor of yellow belly or yellow belly adjacent type thing, but they're all subtly different. But they're differentiating that at that granular scale.
Oh, what? We can't hear you. Oh, Nick, you're muted.
How did I mute my? I didn't touch anything. I swear I didn't do anything.
Yeah, it's weird, dude. Because like I was trying to unmute you, and it says you can't unmute your guest. They muted themselves.
I didn't even touch anything. I sometimes talk with my hands, and I probably bump something without realizing.
Yeah, probably.
The morph testing, it just speeds up accelerates price declines. It's kind of like between that and online auctions. It's just like, are we trying to make this stuff worth nothing? It's like kind of like everything you can do to make the things to accelerate things really super fast.
Everything is like, I don't know, entrepreneurize, sell more, test faster, breed quicker. Now Mac got you right here. You're not gonna like this one, Nick, but Nick, all recessives were always codom, so why does it matter? Laughing my ass off. You gotta give it to this guy. That is say something to him.
I think he didn't understand a single thing I said based on that comment. I don't think that is in no way, in any way, shape, or form, anywhere close to what I was saying.
He should have put incomplete down.
I'm saying that a lot of the things that we call recessive are actually very subtle incomplete dominance. Is not surprising.
He knows.
Everybody knows that.
It's a funny comment.
It's like we all know that that's the case. And some of this stuff, it is sometimes very difficult to tell. So sometimes things appear to meet the definition of this, that, or the other thing. And it's only years and years later, after a lot of breeding and a lot of scrutiny, that you realize that maybe there's a little more to it than you initially thought. And that's normal for that to happen.
Monroe Morphs wants to talk about pleiotrophy.
Dan, get out of here. That's a friend of mine just fucking with me.
I mean, he does have a point. Trophy does play an effect with these recessive mutations we work with. There's going to be these like micro effects from like, you know.
Yeah, it's complicated. It doesn't change the definition of what's incomplete dominant and what's recessive. There are extenuating things that make it hard to interpret results and interpret that data. Things are what they are. Our ability to properly gauge and judge what they are, that's the problem. Sometimes it's very difficult to determine what is part of the mutation and what is the background noise. What is artifacts from this guy's line of whatever that morph came from that's just traveling along with it that eventually gets filtered out. And what is actually part caused by the mutation. Sometimes these things take a long time to figure out, and we have to reassess what we initially thought.
Okay.
And we might have to change our opinions because we have more data.
Yeah.
So Pied is not
I agree
recessive.
with that one.
It's true. That's and we should always be open to that. I mean, we'd never learn anything if we were constantly, this is what I think, and my opinion's not changeable. We should always be open to new evidence, and with greater amount of evidence, we will likely change our opinions on things and our interpretation of phenomenon based on better and more complete evidence. So oftentimes, things we initially believe might later be proven wrong. There are things I could list a bunch of things I thought were true, and then 20 years on, with a lot more data points and everything, you find out that things are not what you thought it was. Now we have a better view of things. And in 20 years in the future, we might have an even more refined view of things. And maybe what I believe now might have to change and adapt with that information.
Yeah. What I was going to say with the Pied, though, because, it's not like that community wasn't already used to recessives and incomplete dominance. I think back then there was an understanding about markers, but, it's just the way the lingo had to go because that's just what the market was. That was the understanding. That was so people didn't think they were getting fucked over. Everybody understood the markers to look for. You saw people picking through sets back then for the markers, but... Again,
I remember picking through wild-caught normals looking for markers and stuff when the things were... Because back in the day, I remember when Pete Call proved out the Pied and put them up for $25,000, about circa 2000, and people actually paid it. And it was crazy. So I remember people plucking out and looking through normals looking for markers, and I did that myself. I didn't find anything that, didn't go anywhere for me, but it happens.
With ball pythons, the funny thing is all these small markers just keep on proving out too. I even talked back to the vanilla back in the day, people picking that out of a bag. I think it was maybe Gulf Coast. Putting them together and getting a super, which I think is absolutely insane because I would have overlooked that subtlety in about every other species, and I think we do still today.
I produced a bunch of vanillas, and I'm terrible. I would just only subtle stuff. I had a Super Spectre. I bought a Super Spectre because I didn't know what a Spectre was even supposed to look like, so I just bought a homozygous animal, so every baby it produced would be a Spectre, and even after producing quite a number of clutches where every baby was a Spectre, I still couldn't pick a Spectre out of a lineup. I couldn't tell you what one's supposed to look like. Everybody says it's incomplete dominant. I guess, I don't know. Everything else at that locus seems to be, but that seems so subtle that I was not in tune enough to be able to pick it out with any consistency.
No, a lot of people got pushed over on those back in the day too. They were buying yellow bellies that were marked Spectres. Same thing happened with the Puma project, and you had the Spark stuff. Everything was mislabeled. People weren't making what they were supposed to. It was just kind of hard to identify.
Oh yeah, and then everybody and their brother had their own line of yellow belly they picked out of a bag of imports. And some of them weren't yellow bellies; they were other things in that complex that were kind of like a yellow belly, but not exactly. It's yeah.
So what do you think it is about those genes that you get the ivory all the way to a freeway, which is one of the more darker pigments?
I don't know. They're all just broken copies of the same gene, but they're all broken in slightly different ways that allow more or less pigment synthesis or distribution. And as far as
they're very similar.
Yeah.
Oh, well, the patterns, if you look at an ivory's pattern with just that little bit of back pattern and put it next to a freeway, it is almost identical, just a completely different color.
Just a little bit of difference in the protein pathways that are allowed through can be the pretty big difference in pigment production.
I have a question with pertains to leucistic snakes more broadly, because I've never seen one Actually, I think I might have seen one on your table at one
Yeah,
point. But I wasn't
cystic
paying
hognose.
attention.
You're gonna ask about pattern on it.
Do they have? I'm going to go out on a limb, and do they ever manifest any sort of linear, like dorsal dot dash dorsal striping, however faded or faint, or is it immaculate white?
Immaculate white. If you put a black light on them, there's nothing. Every now and then you can get a paradox or some pigment comes through.
Well, that's That's something
You're right.
else. But,
Yeah.
But usually there's like a there is
Nothing.
like a linear sort of aspect to all of these things, which is why some of these combinations result in striping, and when you see pattern on them, it's always in the same
White as
in
snow.
that sort of area.
Very white. Very
What?
white. Now the bellies can sometimes have like some translucent scales. But yeah, dude, there's no pattern. Maybe there's some faint pink eye striping right here. But I think that might be like I'll have to take a better look. Some do get a little bit of pink right there. They do.
That's just shutting the process down at the earliest possible step. And just so virtually nothing goes out, and you end up with
nothing goes out except for like the pink by the eyes. That's it.
The head is in vertebrate embryos. All the pigment comes out of the neural tube, which is basically correlates to the base of the spine. So
Sure.
the first area that gets pigmented is the head, and the last area is the ventral surface.
Yeah, okay, that makes
So
sense.
it's like-
why the eyes
That's
get
like
a little bit
that's like the first thing that because the end of the neural tube where the pigment migrates out of
It's
is
gonna be
basically at the base right behind the head.
Yeah,
So
exactly.
the first stop on that process is there, and that's why when you see other types of leucistic and ball pythons, where's the pigment that they have mostly? Oh, like a super mojave. It's got
The head,
purple head,
yeah.
because that's the area that gets the first pigment. So it sounds like the hognose version of that mutation just shuts it down at the extremely earlier than even any of the ball python versions. You know.
Yeah, it's very there's basically like no pigment. It's like it's gone. Yeah, even subarctic lucies are pretty neat because the subarctic affects iridophores. So then you get an animal that's more translucent, and you get areas that are translucent and patches that are not. So sometimes it can have like a clear and white calico effect.
So you have like white and clear.
Yes.
Which is weird because white isn't a pigment. White is the absence of all pigment. Being translucent is
White's
really weird.
absorbing light. So it's basically the scales. That's why it's scale structural difference. So the platelets, the iridophore platelets are different. So certain scales allows more light through, appearing more translucent. The other scales are absorbing white, kind of, or light.
I'd like to humbly suggest your next project that you'll make $1 million off of, and if you can, you should selectively breed those to make entirely transparent snakes. Could you imagine
you can't really,
a jellyfish? You can just see its organs. Everything. It's like get after it. It's like you get partial translucence. Could you selectively steer towards more and more of that? Like
the most iridophore reduced mutation in hognose is subarctics. That's as far as they're gonna get. But I would like to make a translucent hognose if I could. Their scale structure, though, wouldn't allow that. Their scale structure is so coarse and keeled. It's like a rattlesnake scale.
Yeah, I mean, you can have mutations to scale structure, too, but there doesn't seem like there's it's not like a one gene sort of situation. There's never been like a morph where, the scales are now keeled in one step. Or it doesn't seem to work like that. You definitely have keeled scaled snakes, but it doesn't appear to be like a single gene mutation that gets you there. Probably a lot of iterations along the way. Usually keeled scales, it'll be like a ridge down the middle, like the vein in a feather. It'll be like a ridge down the middle, and then causing the keel. It's not usually just a scale that's just upturned. If you look at it under magnification, weirdly, there's a picture of a death adder on my screensaver I took in Australia on one of my trips, and it's kind of got keeled scales, and I'm looking at it right now, and you can see the little vein down the center, which is really a common feature for keeled scaled species.
Yeah, that's interesting. Has there ever been a scale mutation? And somebody has asked if there's been a scale mutation in hognose. Not yet. I did have one that's partially scaleless on the head, but I think it's just random. I bred it. I didn't get any offspring that were expressing anything.
Yeah, let's hope that doesn't happen. Like, do we need scaleless hognose snakes?
Scaleless
no, we do not
hognose,
need that.
no, it would die. You would need to have a partial scaleless. It would have to have most of its skin. It'd have to have its rostral scale, upper labial, scoots, and like the chin plates, all that. The scales there need to be intact. They're also hognose because they're meant to burrow. Their instinct is to push and burrow. So you cannot have a snake like that doesn't have protection on its head.
Yeah, I'm not in favor of scaleless snakes. That is a bridge too far. It doesn't.
Scaleless corns do pretty good though.
There's no such thing as a scaleless corn. They're
scaleless
hybrid.
Scaleless.
They're hybrids that we call corn snakes out of convenience, but there's no such thing as a scaleless corn snake.
Are you sure they're hybrids though? I still
Yes. Yes, they are hybrids. The original scaleless animal was a Great Plains rat snake, and they just back crossed into corn snakes for so many generations, and then call them corn snakes. But they're all hybrids.
Okay. Again, this is just somebody talking at a show, but they had spoke about breeding their scaleless corn snakes or their scaleless rat, and they didn't make scaleless babies.
Well, you can have more than one type. I mean,
True.
You can. There are different. There's two types of scaleless mutations in snakes. There's the type that still retains ventral scales, and usually they also have like a few random scales on the body and the head and on the body, just in random spots, and they'll have belly scutes like the scaleless corn snakes. Those can do all right. I would never breed them or keep them, but they can do all right. It's not a death sentence to be a scaleless corn because they have ventral scales. The other type is utterly and completely devoid of scales. Those do not ever do well. They tend to go into, the ball python ones are the completely scaleless type, and you see how well that worked out. The completely scaleless type, that mutation, just does not work.
No, everything about the scaleless ball python was a disaster. I always said too, like just right off the bat, the sheds, and we might have talked about this last time, but without any of the any scales on it, when that shed starts rolling down the body, nothing makes it stretch. It gets tighter and tighter to literally it's like a condom, like on the so
Yeah, I think it's some things. I mean, look at the scaleless bearded dragons. What a nightmare that is! Like it's just
lather them up.
Yeah.
No,
Get your udder cream and lather them up, son.
You just let them go extinct. Just let them die out. This is not. We should not be making scaleless lizards or scaleless, completely scaleless snakes. Anyway, it's too far. It's not cool for the animal at that point.
Maybe a couple corn snakes now and again, but yeah, I get what you're saying, man.
If they can live a normal life and eat, shed, shit, and do normal snake stuff, okay, whatever. I don't have a problem with it, and they're cool looking. I mean, I see the scaleless quote unquote corns periodically. It's beautiful. It's weird. They have that look. They're really weird looking. Yeah. I get why people think it's cool, but it's a hard pass for me. There was a guy that hatched out a handful of scaleless short-tailed pythons. I think they're Borneos.
Oh my
God. I was like, did you see that?
Yeah.
And they were completely... And then they were completely scaleless like the ball pythons. And he said he was going to let them die. And it's just like... I mean, not kill the babies that were scaleless, but he was just not going to make any more of them and wasn't going to introduce us to the hobby because it's going to be like you think it is. I'm like, wow, I respect that dude. And it's been a few years. I haven't seen anything else, so maybe he made good on it and just let them live for as long as they're going to live. And we don't need this. This is not good.
Blood pythons don't really even move that much, though. It'd probably do okay.
Yeah, except for they like to live in muddy, swampy, gross stuff. Like it's like with no skin. It's like, ugh.
Yeah, you're
too
right.
much. I just,
No, I think as soon as he made those, he pretty much just said the project was over. And like the first thing I thought about when they were born, how the first shed cycle would go. Because again, scaleless ball pythons were always in shed, and the bloods take 4 to 6 months to shed. I think it would have probably shed really early because of it.
Yeah, they can take a long time to shed. And again, beautiful. They're beautiful.
Hey,
but
Nick, there's one. I gotta get you pictures of it. They're scootless snapping turtles.
Oh,
what?
Scootless snapping turtles, man. They almost look like soft. Like their scoots are like really diminutive, and they almost look like a soft shell turtle. And their faces are all smooth. There's basically a scaleless version, but in a snapping turtle. They're weird as hell.
Yeah, that's not good. That's not good for the turtle.
I showed him a couple of turtle people, and he just put LMAO fucking just put that thing in the freezer. I'm like,
Hey,
that's
did you,
brutal.
hey, do you guys remember the scaleless Selcata tortoise?
No.
Oh my god, you gotta Google it, dude. It was the craziest thing ever. Is that showing up?
It's
Oh
cute.
my god. Yeah, it's cute. It looks like an alien. I mean, but I just think
It was blue, man. There's videos of it walking
I think-
around. It doesn't even seem real.
Is that the fucker that built the pyramids?
right.
Yeah, maybe.
I think the hobby, we need to be a little more ethical in what we choose to do. And there's at some point, like, some things are just not cool, and we shouldn't do that. Like, it's like mutations pop out, but I respect the guy that let the blood python, the Borneos, just go away and not produce it, just because that's what needs to happen. I think that we give ourselves a bad name by pushing this sort of stuff. You know, we have enough data on scaleless snakes. We don't need to see how it goes. It's like this time it's going to work. It's like it never works before. It's never worked ever. But this time it's going to work. It's not going to work.
How about this one, guys?
Well,
How about scaleless snake? How about sailless snake?
What?
Sailless snake. You can't sell it because.
It's got no scales. Like, or it died. Like,
hey, you guys.
Either one.
Wait, look at it move. Look at that thing thriving, man.
it looked like it just came out of the egg. It's so small. I don't.
Yeah. I don't know if it made it. I haven't seen any updated pictures.
Yeah, probably not. I don't imagine like how.
You don't
How
see
would you-
ball pythons anymore either, man. I
You
think
what?
the community let it go.
Yeah, it's like that. Remember, it's like the desert ball. Remember that? That was pretty cool looking. And then like, oh, the females are basically always just die when you go to breed them. It's like,
I'm gonna say something. I don't know if it's right or wrong, but I'm breeding my desert male for the first time this year in like 10 years.
you have one?
Yeah, I have. Ben had a Hydra Champagne Desert, and it makes like lavender babies with like little like bright yellow pattern like neon. They're really funky, but they're absolutely beautiful.
I haven't even seen a picture of one in so long. People just like gave up on that a long time ago. I'm surprised there's any around anymore.
A couple people got him. I was talking, or Babu, we were talking. I think he's got an Xanthic Desert in his collection still, and I think he might breed it this year.
I mean, you could, I guess. I don't know what you can do with the female babies. Give them away or something. But it's like kind of.
That's pretty much. I mean, as long as the female doesn't like ovulate as a pet, you don't really have anything you have to worry about. But if she ovulates, yeah, you're fucked.
Yeah, I mean, it's. I don't know. I mean, as long as these things aren't like ruining the quality of life for the animal, then I guess I don't have a problem with it. It's like.
Yeah,
Oh.
and the one thing I'll say too, I don't think I've ever had many people, if anybody at a show, talk about how their pet ball python just ovulated on it. You know, like it's really not a common thing.
No, not unless you put a male in there. It turns out they don't just spontaneously lay clutches. It's not really a thing. I mean,
Well, Partho would be a concern, but even that's a rarity in ball.
usually when you see Partho clutches, there was a male around, you know, and everything. And he may not have sired anything, but his presence is probably part of the process. But
one of the
that's
early-
rare enough. That's a rare enough occurrence to not really have to worry about it. I mean, yeah, I guess it could happen, but it's.
No, I agree. So I brought, or one of the questions earlier was about like ovulation on one side, and the other side ovulating afterwards.
Yeah, it's
The
Lisa.
hobby with boas, I brought it up on another podcast, but she ovulated on one side and then ovulated on the other. She parthoed the one side, the other one was sired by the father.
Oh, that's weird.
Yeah, it's really funny.
These things I'm sure do happen. I have had numerous times where I'll have a clutch where like half the babies hatch and then like a few days go by and the other ones don't come out of the egg for a couple days longer. Like you get like where you have like an A group and a B group. Usually that's not the case, but I've had that happen enough. Or I've even had like one egg will hatch like really, really super like a week before the rest of the clutch hatches. You know, you do get that sort of thing once in a while, so it's certainly probably possible. Oh, there's Lisa.
You can answer the question if you read it.
I've got the. Oh, now I can read the whole thing. I have a split between I have two monitors, and I have the window right in the middle where my camera is, so it's easy to look at the camera. So I have to move on the side so I can see it now. About the staggered ovulation, you think sometimes pythons? Yeah, I think that's very likely they do. I know of several pythons that have lost an oviduct. Like they will prolapse an oviduct with the eggs in it, and you have to amputate the oviduct, and then the cloaca, and the rest of it sucks back up in. And those animals you think would never breed again, sometimes can in fact successfully reproduce, but they're only firing on one side. So you'll get like a half a clutch. Like 3 years later, you get like a half a clutch because they only have the one remaining side. That wasn't the problem.
That happened with a corn snake that I know somebody had. Lost one of its whole oviducts, and then it would just lay small clutches from.
Yeah,
of course,
I've never.
You're just getting half a clutch.
I've only tried to breed one snake that was in that situation, and it's a female pygmy python, so a very valuable rare snake. And I gave her a couple years after she lost the oviduct, and she would build follicles on the one side and go through like a false pregnancy. So I put the male in there, and she fucking ate him.
What?
She literally killed and ate the male, and then regurgitated him like 5 days later. So I have not put it, and it's really hard to get a male pygmy python, like really hard. Males are a lot harder to find than females. Like, I ain't doing that again. Oh yeah. I think because they sometimes starve themselves. Like they just don't, sometimes you don't get them all eating. If you get 8 babies, you're probably not going to get all 8 of them going. It's very common to lose 1 or 2. And I think the ones that are starving themselves are the disproportionately males. Females have a steeper hill to climb to get to reproductive size. And so I think that just makes them a little more agreeable on the food. They're horrible, but the males seem to be even more horrible.
What if you give them little lizards?
Yeah, I'm not doing that.
Okay.
I have never fed a snake a lizard. Ever. And I breed, this year with like the
Antaresia. I hog those geckos sometimes, dude.
If I had the geckos, I totally would. I'm not morally opposed to it. I just haven't. I think I've got 17 gravid Antaresia this year. 17. Oh, wow. Including a whole bunch of little micro babies that all want to eat lizards. And they're not getting any stinking lizards. But it's, I don't know what I was thinking. I think I hate my life is what I think. Like everything I put together in the Antaresia seems to be gravid.
Do you have any pygmy pythons available now? I had somebody ask me a few weeks ago if I knew somebody had them.
I'm going to say no. I have 5, and they're all eating pinkies now, frozen pinkies off of tweezers. But I need to sex them all, and I need to keep at least a male. And so far, I've sexed 2. 3 of them I haven't sexed yet, and the 2 I sexed are both females. Like, I need to keep a male. I have like 4 females and 1 male, and the male's like 16 years old. I need a male, or 2. Like, I'm not selling anything until I know if I got a male. So I give people all the time, I'd really like to pick up a pair. It's like, yeah, no chance. Like, what?
Dave, what do you have an extra female to sell? I mean,
I will absolutely have a female because I already have. I've got to trade to Ryan Young. He needs a female from the bloodline I have, and I need a male from the line he has. What?
How often do they cannibalize the pygmies?
They're murderous little bastards. I can honestly tell you that I have had 3 pygmy python adults die ever. And every single one of them was murdered. I have never had a pygmy python die of natural causes. They are always murdered by pygmy pythons. I've had a male kill another male. I had a female kill a male. I had a female eat a male.
So this is homicide.
Yeah, no, it's all killed. It's usually like, I had a female constrict and kill her mate. I had a female eat her mate. And I had 2 males. I put them together for just like 10 minutes to wrestle a little bit and get them riled up. And one of them killed the other one. Real fast.
All right. Matt asked the easiest question ever. Is what do you think about people breeding crazy odds, trying to get like stuff, blah, blah, blah. And they get undesirable males, like double posset males, and they put them in the freezer. Is that okay practice? Nobody's going, why the fuck are you producing stuff? Because basically you're saying you're overproducing. And then so you're freezing your overproduction.
I think if you feel you need to kill a certain percentage of the things you produce, you need to reevaluate what the fuck you're doing, probably. What are you even doing this for? Like, do you actually like snakes? Because I have never reality is, if you produce snakes at the scale that I produce, and I'm sure you produce far more than me, but even at the scale I produce, 300, 350 babies a year is usually what I try to produce. And even at that scale, like every year, I have to put down a few things. It's part of working with animals, because you hatch 350 baby pythons or hognose or whatever. You don't get 350 perfect ones, do you? There are always a couple out of that 350 that are going to be defective in some way. And even still, behind me, I have 3 babies from last year. And I will spend ridiculous amount of time getting babies I can't even sell feeding just so I can give them away for free. I have there's a female rough scale python with an inverted kink in her neck that totally eats normal sized food and is totally fine. I can't sell that snake, but I'm not going to kill her, and she's broke. I've got an exanthic popwind carpet that's 100% het for granite with a very minor kink that you can feel it, but you can't even see it. But if you run through your hands, you can feel it. I can't sell that snake, and I struggled. I got that damn thing going, so I'll give it away to somebody. I don't kill snakes. If I have to put something down, it's because the only time I will put something down is if the nature of its defect prevents it from living a normal life. It can't eat, shit, or shed. One of those things. If it can do all those 3 things, I will struggle for a year of assist feeding just so I can give it away to somebody as a pet. I don't kill snakes willy-nilly. And I've got some snakes that I don't know why I struggle with it, why I bother with this, but I do. So yeah, I would never condone euthanizing perfectly healthy snakes. You should reevaluate what you're doing if you feel you need to do that.
I mean, whenever we're working on a project, if we have double or triple het males and they're extras, we just sell them as normals. Just put them in a pet trade. There's no reason not to. They're not going to resurface.
No. And also, I'm not going to kill them. That's crazy. To me, that seems crazy. I like pythons. I like snakes. I definitely don't want to kill them.
That's why we're all here. I like snakes too.
You do hatch snakes, and I know you've had it happen too. Where look, your heart's on the outside of your body, or that sort of thing.
Yeah, that one dies fast.
I had a ball python that's brain was on top of its head, not in its head. Its entire upper, rostral region was split. So it had a nostril, and its head was shaped like a V, with a giant cleft that went all the way back, and at the base of the V was the top of its head, and its brain was sitting on top of its head, and it's this V-shaped head with a nostril at each end. Obviously,
so it was that Aliens movie from the 90s, Invasion from Mars. The Mars.
Yes, it was, and then it had this giant split. Its head was bifurcated. Obviously, that's not gonna. It cannot. It can develop in the egg like that. It can never come out of the egg.
Now, serious question: Do you think that was the first intelligent ball python that was ever hatched?
What?
I was going to say,
never mind.
It was the brain, because I didn't know ball pythons had brains.
It seemed, frankly, a bit bigger than I would have guessed, but my guess is that the brain tissue was able to expand because it wasn't confined inside a bony skull. Since it was sitting, there's literally a hole in the top of the skull, and it was just on top. It was all messed up. Lower jaw.
Poor snake.
The lower jaw was basically non-existent. It was completely a mess, but I remember the very first time I ever bred snakes, I thought I was going to be a millionaire. The first time I ever bred anything, and this is 1995. The first time I tried to breed snakes, I bred 4 female carpets, and all 4 of them laid. So I'm like, holy shit, I wasn't prepared to have 100% success on my first attempt. And I bred Diamond Coastal Intergrades, because this is a long time ago. It was one of the clutches. I didn't understand the nature of hybridization and intergrade zones and any of that stuff. I was a newbie.
Yeah, young Nick hybridizing.
I was a newbie. Well, I was breeding animals already hybrids, but I was a newbie dipshit hobbyist who didn't know. I thought, well, they breed in the wild, so that's fine. Not understanding that's completely not what's going on.
MJ, please clip this, but leave out the parts where he said he was young. Make it seem like he did it recently.
Right, recently, right? I'm just saying, this is there's a learning curve for everybody, and I certainly had mine, and there's 23 eggs in this clutch, and one of the eggs, I cut the eggs after the last eggs after the next day, and there was a baby in it that never came out of the egg, and I finally peeled the egg open a little more, and it was a patternless white snake, like a live leucistic carpet with a weird purple sheen to it. So imagine a solid white snake, a purple sheen over the white. And I'm by this point, well, I'm rich. I'm counting imaginary checks. At this point, this is going to be the greatest thing in my life. And the next day, fucker still wasn't out of the egg. Like, that's weird. I couldn't see its head. But I'd poke its body and it would twitch and it would move. And then the next day, it wasn't out of the egg. So like 3-4 days later, it's still in the egg. So I cut the egg open and I scooped this fucking thing out to see what's going on. This is like almost a week after all the other ones were out. And the reason I couldn't see its head is because it didn't have one. Its spine, where the head was, just rolled into like a ball and was fused. Like a rolled up ball of spine and no head. No actual head, but it must have had enough of a brain stem at least to keep its involuntary, the heart pumping and that kind of stuff. Obviously, so the leucistic carpet project died very quickly at that point, as it was non-viable. But boy, I was all about like, oh my god, like this was unfortunately in the days before digital cameras existed, so I didn't even there's no surviving pictures of it even. But yeah, obviously that project didn't go anywhere.
You didn't repeat the pairing to see if maybe the second time it would go better?
Well, no gene expresses itself one time on one egg out of 23. And I bred those same parents the next year and had like 20 more eggs. And no, not because I was expecting that, but it's obviously just a developmental thing. And like, I shouldn't be surprised that its pigment didn't develop right. Its head didn't even develop right. Like it's just like it was a mess. But a perfectly developed body, or mostly, it was a little smaller than it should have been. But it was all there, and then just this ball of spine with no head. So
you know how it is. You generally, when you have like these defects, they typically have weird pattern. Like say they even come up and they just have like a little kink or a few kinks. Those ones a lot of times, they not always, but they can have more erratic or bizarre pattern because things didn't developmentally go right. And so it doesn't affect the animal's widespread, even pigment.
That's something else people, I mean, oh shit, we've been on for over 3 hours. I gotta get running, but people should probably understand that there's a big difference between a developmental problem and a genetic problem. People think like, oh, you can't breed that. They think like it's like that's developmental. You could breed that developmentally challenged animal and it would not pass on to the next generation. A genetic defect would, but a developmental one not. Like a case in point, like something like you ever hatched a one-eyed hognose snake or a no-eyed hognose snake?
I've hatched out no eyes before. It's not genetic, Yeah,
you could breed your no-eyed or one-eyed hognose all day long. It's not going to make a bunch of one-eyed snakes. It's an unfortunate developmental anomaly that happens.
Yes,
I found
I agree there.
I was in Fog Dam, Northern Territory, Australia, and I found a water python. There was a full-grown, big-ass adult, and it had one eye. It was just hatched it was smooth. There was not even it didn't lose an eye. There just never was an eye. It was just blank. And this was a full-grown adult. Robust, healthy, was living its best life, born with one eye. No problem. You don't find a bunch of one-eyed snakes near there either.
I've had three no-eyed hognose. And it looks like it's just scaled over. It's smooth. Yeah. And the funny thing is their accuracy with eating is very good. It's not really off from like one with eyes. And I always call them the same thing. I always title them the Eyeless Wonder. And people always like fight to buy the Eyeless Wonder. I always sell them just for like $200. I don't ask anything extreme, but I don't want to give it. I just want it to go to a good home. But I want to make sure the person's gonna, not just gonna get handed over. The Eyeless Wonders are pretty prized.
I hatched a beautiful Palmerston locality jungle that was missing one eye, and I should have kept it because jungle carpets have like an ocular stripe in front from the nostril. It goes through the eye. The eye breaks it up, and then it continues onto the back. So the whole side of the head has a stripe. But on the smooth eyeless one, where there was just smooth, there's no eye, so the stripe just went right through.
Oh yeah,
the pattern was complete. Like it was interesting, and it ate great and did great. I should have probably kept that one, but usually I always have like, I'm sure you guys do too, where you end up with that sort of rogues gallery of I don't know what I'm gonna do with this snakes. Like I've got several behind me that I don't know what to do with these things. Like they're just like for whatever reason.
Yeah, I had a real high-end hognose that hatched out with almost like a 90-degree kink, but it ate really good and did really well. It wasn't quite 90 degrees, but he was doing really good, and I ended up selling him. He's normally like a $3,000 snake. I sold him for $100, and his name was Bendo. I raised him for about a year.
Yeah, I don't know. Usually I just give that kind of stuff away to people, but I just like...
No, I need
I-
$100. I need
I
to
don't-
make sure the person's willing to have money or buy it.
I don't put
Sometimes
things up.
sometimes I do give it for free, but not often.
I don't give things away if people ask for free snakes. Like it's like if you talk to people, they're buying this or that. Like they seem like the right person. I'll just like, hey, would you?
That's good.
I'll just give it to them. That kind of a situation. I do not want to see these things then getting resold later or that sort of thing, which we've all seen that happen.
Yeah. I will be honest, when I go to a show, same that he's saying, if I ever have any animal that has any kind of defect of any kind and I put it out for just, again, a small amount, just so the guy doesn't just take it, it's the first thing I sell every show, every single time. Guaranteed, always the first animal off my table.
Yep.
There's people that want to nurture something that's fucked up.
Yeah. It's true.
All right, guys. Yeah, I think we're the same thing. It's been 3 hours. Thanks, Nick. It's been a fun conversation. Love having you on, man.
Anytime.
Really appreciate you coming on and sharing some cool information. Love debating and talking about the incomplete dominant resistance stuff. I love that part. Dave, thanks for dunking it up down there with the cap and everything. Always appreciate you, dude. And I'll talk to you guys later, and thanks everybody for joining.
All right. Great being here. Bye.
Yeah. You guys can follow Nick. He's got a book. He's actually got a couple books on pythons. Big Antaresia guy. You can see him at shows out of like Puyallup area. Goes to the Pack and WRS shows. I go out to those shows usually as well. And you can see Dave and I in Tinley and next weekend. So come out to